So yeah, you're going to be able to identify your strengths and weaknesses across the 4 exam domains. You'll understand or be able to describe the technical concepts and technical topics that make up each exam domain. So at least you know what's in each of these 4 domains. You should understand generally what the exam looks like. So we're talking about the mechanics, right? Like when you show up, what does a multiple choice question look like? We're going to go through that pretty quickly because I'm going to guess anybody who's looking at this specialty has already taken architect, associate, possibly architect pro, maybe developer, and DevOps. So yeah, you've probably seen an exam before. And yeah, being effective with your test taking as well as your study strategies. And everybody has a different way of doing these things, right? Like myself, I love to fail fast. Now, I know that sounds horrible because you're probably thinking, dude, I'm here to not fail, right? So of course. But I try not to stress myself out when it comes to an exam because again, like I said earlier, one of the best things you can do for learning as well as I think for exam taking is not to psych yourself out. Don't stress yourself to the point where you're frozen and you don't know how to answer something that you already, you know, right? So I actually feel that each of us can be our own worst enemy. At least that's how I am. But again, to each their own. We'll talk about different approaches that people use. So about the exam itself, we're going to validate your ability to build, train, deploy machine learning models, of course in AWS, right? And diving a little bit deeper into that, select and justify appropriate machine learning approach for a given business problem, identify appropriate services to implement machine learning solutions, and design, implement scalable, cost-optimized, reliable, and secure machine learning solutions. So if you already have your architect associate exam, or you've studied even for your cloud practitioner, number 3 is kind of aligned with that. You already have that because that's sort of, we're basically saying, hey, even if you're doing machine learning, you still have to apply basic best practices in AWS. So the 4 domains. I did mention the exam is broken down into 4 domains, and here they are. As you can see, the majority of it is spent on modeling because that tends to be the fun part of machine learning. You know, it's designing new algorithms and tweaking different hyperparameters and just poking around. But the thing is, you still need data. Okay, so these 2 components right here, data engineering and modeling, comprise over 50% of the exam, as you can see, right? And when you're doing machine learning, I would say it comprises over 50% of what you work with, right? So, but there's also EDA, exploratory data analysis. This is sort of the common sense part of machine learning. Sometimes machines are not the best. Humans are still pretty good too, right? So we're looking at a pie chart here. And this is a visualization to help us understand what proportion of the exam is allocated to what domain, right? These visualizations are designed to help us humans better understand the data. So don't forget that humans are involved in this whole process. And that's what I think the EDA part is, right? So, but yeah, and then we have to talk about operations. As you can see, this is the, well, I mean, it's still 20% of the exam. It's not going to make or break your exam necessarily, but you do need to know what S3 is. And you do need to know that you can encrypt data, for instance, in S3, things like that, right? Because, like I said, we're working with data, and a lot of times data is, well, sensitive, right? It's going to be that data that, well, that needs to be kept private, right? So what about the exam itself? Well, the testing centers. So the exam is 170 minutes, approximately 65 questions. Notice we say approximate. Physically, there are 5,000 testing centers, but please be aware that right now, globally, there is an event occurring that might impact the availability of some of these testing centers. So you do need to check with Pearson or PSI if you decide to take your exam with PSI to see which center or centers happen to be open if you wish to do your exam physically in person. In addition to this, we also have remote proctoring available through Pearson. So what this means is that with a webcam and audio, you can actually sign up for the exam and take the exam from a relatively quiet space. Okay, so I will give you guys some links with respect to this information, and you can go to Pearson as well to read up on this. And they've got lots of FAQs about how to actually prepare your environment for successfully taking one of these exams. The benefit here is that you can stay socially distanced and also stay well in your own the comfort of your home, or I suppose your office. You do need to bring 2 forms of ID. One must be government issued and have a photo. I believe one also has to be signed, although my experience has been that they usually want to see both of them signed. So there's a link here, what to expect in a Pearson VUE test center. That's if you are going into a test center. And by the way, these links will be provided to you in a follow-up email at the end of after this session is done. And with the remote proctored exam, if you, again, are not interested in going into a physical testing center, you can go to this link here for more information on how the remote proctoring works. I've actually taken a few already, remote proctored, and years ago, actually, we used to have stuff like this at other vendors. So basically the webcam is there just to make sure you're not cheating. Same with the audio, the mic has to be left open to make sure somebody's not talking to you or feeding you answers, that sort of thing. So the user interface, let's look at this really quickly. You're given a question, so here's a question, and you're given 4 possible answers, and you would select the one that you think is the answer. By the way, a capybara, there should be a P there, is an interesting animal. It's the largest rodent in the world. There's a fact that maybe you didn't know. I love capybaras, actually. I think they're the goofiest looking animal ever. Yeah, I probably got this one wrong, but I'll select that and then I'll click next, okay, if I want to go to next. If I feel I'm not confident in this answer, I might select flag down here to label this question to come back to it. And as you can see here, there's a counter at the very top right to let you know how close you are to being, to running out of time, right? So I would recommend maybe not focusing on that, all right? I would focus on the question, focus on answering questions as best as you can, and I tend not to dwell on the questions I can't answer. I take it as a learning point and then move on. I might flag it, but personally, I don't use the flags really. Because I never want to see the question again. I'm like, I've answered it, I'm going next. So what about scoring? So you will know right away when you're done with the exam whether you passed or not. Okay, so upon completion, you will, the interface will tell you, right? But within 5 days, you will receive an email with an actual report as well, right? And you'll see the results in your transcript, but it does take a little bit of time to synchronize into the transcript and for you to receive officially the certification from AWS. And you also get a kind of detailed score report. We're not going to give you a breakdown of each individual question, but rather we show you which domain you're doing, well or not well. Okay, so you do not actually need to pass each individual domain in order to pass the exam. You just need to pass the exam. All right. So here's the deal. It is multiple choice or multiple selection questions, and the question is either correct, your answer is either correct or it is incorrect. That's it. It's binary. It's that simple. So if it's one of those select all that apply, please choose 3. If you choose 3, but one of those selections is incorrect, you do not get 66%. But here's the other thing to take from this. Since all questions are either correct or incorrect, you don't get any penalty for selecting the wrong answer. Okay, so we don't subtract points from your overall score if you just take a guess and you get it wrong. So you're always best off to at least take a guess if you have no idea what to pick. In the case of a multiple choice exam, where there are, let's say, 4 choices, you still have 25% chance of getting that correct, right? I mean, so it would not be a good strategy to leave the question completely unanswered. Again, don't leave any questions unanswered. Mechanics and design for the questions. Well, the questions may be multiple choice, like I said, where you only select one of the choices, or you may need to select multiple choices, or multiple responses, I should say. So with the multiple response, we will always tell you how many you need to select. And the interface will warn you if you don't do this correctly. So if you accidentally choose 3, then you'll get a warning. But don't count on the warning. You should actually read the question, and we'll talk about that shortly, before you answer it. And it clearly says here, select 2. So you would select 2, not 1, not 3, exactly 2 choices, right? Remember that if you get even just one of these wrong in the question, the entire question is scored as wrong, okay? So this is a specialty level exam. It's considered a 300 level exam, which means that we're going to be, the questions will be a little different. We're not expecting you to memorize a bunch of stuff that you can recall. Those are more the associate level or even the professional level type exams, right? The specialty exams, we really want to focus on synthesis. Can you actually take the question and apply, understand, and comprehend the purpose behind the answer? Not just, S3 supports what encryption algorithm, and then, you just need to pick AES 256 or something like that. This is more like, we're going to look at some sample questions, so you'll get a chance to see what we mean. But it's higher level thinking, and it's, as you can see here, we're just one step away from the very top, which is creation. And so this is still a form-based exam. We're not actually asking you to submit code snippets or anything like that. So exam questions do focus on a scenario. So here's an example. A data scientist is working on optimizing a model during the training process by varying multiple parameters. The data scientist observes that during multiple runs with identical parameters, the loss function converges to different yet stable values. What should the data scientist do to improve the training process? Now, when I first see this question, I would tend to read the question first, and then I would go back to read the body. And actually, I tend to look at the questions, the answers as well. But be careful with this, because a lot of times, in fact, if it's a multiple choice question, there will be really only one choice that is best, right? The rest will be what we call distractors. That kind of sound like they might be good choices, but they might not be, all right? So, yeah, so just be careful about this. Now, we're not actually looking at the content of this question in this particular slide. We're just pointing out that the format of the exam is to not try to fool you, but to identify, well, guesses, right? I guess that's basically what it is. So when you're reading the question, look for qualifiers that could help you eliminate answer options. What do we mean by that? A company is interested in building a fraud detection model. Currently, the data scientist does not have sufficient amount of information due to low number of fraud cases. Which method is most likely to generate the greatest number of valid fraud cases? So we're trying to maximize the number of valid fraud cases, or greatest, right? And also we're saying there's not going to be, it's not black and white, the question, right? So you want to eliminate the least likely options. So for instance, you might go with synthetic minority oversampling technique, right? Undersampling is not going to help you because that's the opposite of what we're trying to achieve. So this is just a bad choice. And random oversampling, I mean, oversampling is what we're trying to do here, right? But SMOTE probably will give you the greatest number of fraud cases versus random oversampling. And class weight adjustment has nothing to do with this, right? Now, if you have no idea what all these things mean, then you might be fooled into choosing one of the distractors, right? And that's a pretty, I mean, the whole idea here is to identify if you don't actually know the domain, then, well, we want to score accordingly. So, and look for key phrases that may imply a service or a feature. Right here, automate running transformation jobs. Those words stick out to me. And without even looking at the answers, I might be able to already guess what services AWS might want us to pick, right? It's funny because I actually work for AWS. I shouldn't say they may want us to pick, but when I'm taking an exam, right, I'm not special. It's me versus the exam as well. So anyhow, creating an Amazon EMR cluster with Hive installed, then blah, blah, blah. If you know what Hive is, it's based on HiveQL, and there's nothing about this as automated, really, right? I mean, you could have a Hive script, I suppose. Spark, same thing. You could create a Spark script. But, of all these options, the one that already popped into mind before I even looked at the answers, the possible answers, is Glue. And if you've been, so really the trick here is that you need to pay attention to what AWS has been saying, right? We're very proud of Glue. And we feel that Glue is built for automating transformations. It's our ETL tool. So even before you look at the answers, you should have already been looking for the word Glue. Simple 4 letters, find those 4 letters, pick it, and then usually, like I said, when I'm taking exams, I try to spend no more than 5 to 7 seconds per question. I try to be done within, and I don't recommend this, by the way. This is not a strategy for success for most people. But like I said, I like to fail fast. So I already know I'm looking for Glue. I find the Glue, and then I quickly scan the other answers to see if Glue is mentioned. If not, then I just click next and move on. But I recommend you actually read the other answers. The challenge there is that you might get distracted. Right? That's why they're called distractors. They're meant to pull your attention away from the actual correct answer, right? But the thing is, we're not trying to fool you at all, right? Like, if you look at this question here, a company is setting up a system to manage all data sets it stores in S3. Company would like to automate running transformation jobs on the data, blah, blah, blah. So the point is, none of these details are distractors, okay? The answers that we give you, the options, there will be distractors in there, but the actual scenario will not contain any distractors. All this information is necessary, and it will impact what you choose for your answer, okay? Now, some questions may require minor calculations. If you're in a testing center, you will be provided a writing board and an erasable pen. In some cases, it'll be pencil and paper. In some cases, it will be pen and paper. This paper is given to you to be used temporarily during the exam, and then you have to provide this paper back to the exam invigilator before leaving the center so that you can't walk away with exam materials. That's one reason. So now, that's in a testing center. But if you're doing a remote proctored exam, this is not the case. You will not have a physical person there to assist you with furnishing paper, pen, and that kind of thing. So the online exam interface does have like this notepad you can use. You can open it up on the side and type your notes into there. But the thing is, the calculations that you will need to do are so simple, you should be able to do them in your head. We're talking about adding some numbers and possibly dividing, okay? And the answers will be unique enough that you don't have to divide in your head and go to the 20th decimal place to figure out which answer is correct. right? So questions that we won't test you on. We're not going to test you on services or features that have only been available for 6 months or less, or any information that's likely to change. So if you just read a new blog entry from Jeff Barr, or you just saw a news release in the last week, disregard that when you're answering your questions. Okay, so that will not be in the test. All right, so we're talking about fairly stable information, stable ideas. And like I said, the majority of this exam is really focused on general machine learning ideas, which are extremely stable, right? So test taking strategies. During the exam, read and understand the question, right? Before reading the answer options. Again, each person will use their own strategy, but there you go. Identify key phrases and qualifiers. So yeah, look for those key words or those key phrases that pop out that can steer you to the correct answer. Anticipate the answer before looking at the answer choices, like glue earlier, right? Eliminate options based on what you know about the question topic, and compare contrast the remaining answer options. So again, I caution on this point here, you don't want to distract yourself. If you're already very confident in the question, in the answer you've picked, then you're only skimming the other answers to make sure that you're not just being too hasty here. And consider flagging the question if it's really bothering you. Like, don't get stuck, right? I mean, that the worst thing that can happen is you look at the clock in the top right-hand corner, it's ticking down, you're getting sweaty, you're psyching yourself out. Remember I said, if you feel yourself in that mode where you're physiologically feeling that kind of stress, you want to do whatever is possible to take yourself out of that space, right? Because you will perform better on the questions if your body is relaxed. Okay, just trust me on this. Like, if you're sitting on the edge of your seat, and you know, I mean, it's this exam is 170 minutes, right? So that's a long time to be sitting at a computer. So, all right, so let's start to look at these domains. We're gonna just dive right into some domains here. So the first one we're gonna talk about is data engineering. Why data engineering first? Well, it's kind of the first thing you do in your pipeline, right? Like, so you need to ingest data. So this domain is broken down into 3 subdomains: creating data repositories for machine learning, identify and implement a data ingestion solution, identify and implement a data transformation solution. Okay, so we already kind of saw, whenever we hear the word transformation, maybe glue is involved. And when we hear data repository, here's a hint, S3, we're pretty proud of that, right? So there's certain services that should already pop into your mind and say, well, you know, if I really don't know the answer to the question, then if I'm gonna take a stab at it, maybe something related to S3 would be good if it seems like a question related to data repositories. Or maybe something related to glue might be a good choice if, you know. Of course, you don't want to just be guessing your way through, right? Ideally, you read the question and you immediately know which answer you should pick. But, you know, again, you might be stressed out during the exam. So let's look at the first subdomain, creating data repositories for machine learning purposes. So machine learning has to be based on data. We train our models off of data. So the cleaner the data, the better the overall model that you develop, right? So it's kind of like if you're trying to teach a child, like a person, you know, something new. If you deliberately feed that person incorrect information, it'll really lead that child to make poor decisions going forward, right? And the same goes for a machine learning model. You need to feed data in that actually, well, is relatively clean. So to actually get that data in, you might be reading data from all kinds of sources, right? There's lots of different sources for this data. But we need to transform it, clean it up, and store it into some kind of repository, right? And the repository may need to accommodate all different varieties of data. So we might be dealing with MP3s, we might be dealing with waves, we might be dealing with GIFs, PDFs, Word documents, Excel spreadsheets, tweets, maybe TikTok videos, I don't know. So we feel, and I think the industry generally feels, that the data lake is the best repository, the generalized repository for storing all that unstructured and semi-structured data, right? What if you need to ingest a video recording, an MP4 recording? What if you're building a model that is meant to identify happy and sad people? Well, you know, if I take an audio recording of somebody calling an airline saying, hey, my last flight was awesome. Hey, I turn that into text. We have services for that, by the way, right? So you take that recording, you turn it into text, it says my last flight was awesome. Okay. The problem is we've now converted the data into a less rich format. And we may have lost the intonation, the cadence of the speech, possibly the accent used in the speech. People use things known as sarcasm, humor, you know, things like that. And those cues would be lost if we transform the data. So we want to store the data in its original form, if possible. And that's why the data lake. So for that purpose, we might use something like a bucket as our data lake. That's all this is saying. And you need to be familiar with S3 because we feel S3 is the most suited service for hosting your lake. And we have a service called Lake Formation, which you should be familiar with, that can be used to help you build this lake. Because there's all kinds of challenges building a data lake. Regulatory challenges, privacy challenges, so you need to make sure everything's encrypted, access controls are in place, all that operational stuff that, you know, as a data scientist or a machine learning expert, you don't want to waste your time on, but you have to comply with, otherwise your whole department gets shut down. So S3 is your friend in this space. So you do need to know S3. And I know that seems weird because you're going to say, but this is machine learning. Why would I be talking about buckets? Because you use them, right? So be familiar with the different tiers of storage available, all the way from the really hot data to the really cold data. You need to be familiar with these options, their relative costs. So you need to know as you move towards the right-hand side, access times become much longer. As you move towards the left-hand side, access times become much shorter, but then costs are different too. Obviously, costs on the left-hand side are higher, costs on the right-hand side are lower. So less expensive over here, more expensive over here. Although it's not that expensive, okay? S3 is still very affordable. It's just of these options. And yeah, SageMaker, which you may be, well, actually, you should be familiar with SageMaker for this specialty exam. SageMaker absolutely leverages S3 for reading and writing. So we use S3 as our storage system for both our training data input as well as our model artifacts. Okay, so our model artifacts are pumped out as objects that are dumped into a bucket. And you do need to know about FSX for Lustre. So Lustre is a file system, an open source file system that was designed or is designed to be really high performance. I remember back in the day, like 15 years ago, we were using Lustre in supercomputing. So primarily, it was open source, it still is open source, but then Sun Microsystems bought Lustre, a whole bunch of stuff happened, but it's still used today as a very high performance file system. So the benefit here is that if you move your data into Lustre, you can then leverage Lustre within your SageMaker training jobs to get phenomenal throughput. Okay, so Lustre gives you way faster throughput to your training instances than S3 would. It of course comes with a cost. Okay, so this is where, you know, if you see yourself in a situation where a training job is really slow and you want more performance, you might consider using Lustre. Now, it's very important that you pay attention to the word Lustre, not FSX, because we have another service called FSX for Windows, which is really just Windows file shares, and that I would not call high performance. So speaking of file shares, we have Amazon EFS. So if you already have your corporate data, your enterprise data sitting in EFS, then hey, you don't have to move it anywhere. You don't have to lift it out of EFS into S3 before doing your training. You can train directly off of it. So what we're saying in these last two slides is remember that SageMaker can read from FSx for Lustre as well as from EFS. Basically, any file system that Linux can use. And yes, I just said Linux that way. When choosing a file system, take into consideration the training load time. So relative to regular EFS, which is kind of like our baseline here, S3 is a little bit slower. EBS is slightly faster, but significantly more expensive. Notice we did not recommend EBS, by the way, in any of those previous slides. And FSx for Lustre is clearly the fastest. But again, pay attention to the question. If the question says that you want to optimize for speed over everything else, then that's very different than saying what would be the best choice, because the best choice usually will also include economics. The business you're doing the machine learning for actually cares about money, right? So, so here are the services you'll definitely want to be familiar with. There's Lake Formation, S3, FSx for Lustre, EFS, EBS, and S3. Also be familiar with some of the functionality within S3, like lifecycle configuration, and also the various options, the tiers that are available for storing within S3. All right, the next subdomain we want to look at, identifying, implementing data ingestion solution. So here we said you want a data lake, right? And we said that there's going to be data coming into the data lake. But how do we get the data in the data lake, right? So how do we construct those rivers that will flow into those lakes? Well, you could run batches, right? I mean, this goes all the way back to like, I don't know, mainframe. So you have a COBOL job, you run it, but that's not what we're going to recommend, right? So we need to put some kind of compute here to read from the sources, do a little bit of cleansing and processing, and then dump that data into S3. So what are we going to use in this blue box? Well, we might use Glue. So first thing, we just need to land the data into some kind of ingestion bucket where the data has been unprocessed. And then we might use Glue. We recommend you use Glue to run a Spark job to clean the data. So now batches are kind of old school, but batches are still very common. All right, so it's not like it's good or bad. But today, a lot of our machine learning pipelines want to be more real time. So you might want to stream the data in rather than wait for it to be processed every hour or every day, right? So stream processing, well, we have Kinesis. So you need to be familiar with Kinesis, at least be aware that Kinesis can be used for ingesting your streams as well as processing your streams, okay? So just be generally familiar with the various forms of Kinesis, but the ones that I think you will really want to pay attention to would be data streams and data firehose. Okay, so video is kind of extravagant. It's good to know that it exists. And data analytics, you should be familiar with this idea that you can run standard SQL statements against your streams. Okay, so if you have data sitting in a data stream coming in, you can query it directly. You don't have to wait for it to land in S3 and then use Athena. So again, this is just a summary of those services. Glue is also good to know, obviously, because that's like our batch transformation service, Kinesis for streams. And you just need to know that we have managed services or managed streaming for Kafka. Okay, so it's just good to know that we do have a hosted form of Kafka in case you want to use an open source option. And the last subdomain in this data engineering side is identify, implement data transformation solution. So the thing is, the raw data that you receive is not ready for training. You need to do something right here to transform the data from raw to training ready. And so we need something. We need something to fill this box. And we already said that Glue would fit this box really well, but if you need to run your traditional Spark jobs and Glue is not for you, then you can spin up EMR as well. Elastic MapReduce is our classic big data hosted Hadoop. So if you see the word Hadoop or you see something alluding to the use of Hadoop and you already have existing workloads coded in Hadoop using MapReduce or even using Spark, EMR is a good fit for this. Okay, so EMR is our hosted Hadoop. You might use EMR for both preparing, cleansing, partitioning the data, but the point is that this is our older stand-in for Glue. Glue is fairly new. Okay, it's within the last 3-4 years, something like that. So there you go. So we've got EMR, we have Glue. So the thing is, you might say, well, what if a question shows me both as answers, Glue and EMR? Which do I pick? Well, then you have to look for other keys in the question text itself, right? The scenario will say something like, well, you have an existing Hadoop workload, and you want to lift this into the cloud. What do you use, right? So that should be kind of a clue. You can store a single source of truth in S3, and then do ad hoc analysis using tools like Athena, or maybe load it into Redshift. Oh, sorry, we're not loading it into Redshift. We're using Redshift Spectrum. So that allows us to query directly from S3. So all we're showing you here is that you may construct a fairly elaborate pipeline. And here are various services you definitely want to be familiar with, including even QuickSight. Again, a lot of times we underestimate the value of that exploratory data analysis. Okay, so Spark on EMR. Spark works with Sage, as SageMaker as well, and of course we have Glue. Glue is actually a number of different services: Glue Catalog, Glue ETL, Glue ETL Author, and also the crawler. So be familiar with those aspects of Glue. All right, let's look at some questions. I think you guys have been waiting for this. So we're going to walk through a few questions, and then I'll even give you like a 5-minute little quiz you guys can do and test yourself out. So first sample question: a data engineer needs to create a cost-effective data pipeline solution that ingests unstructured data from various sources and stores it for downstream analytics, applications, and machine learning. The solution should include a data store where the processed data is highly available for at least 1 year so that the data analysts and the data scientists can run analytics and machine learning workloads on the most recent data. For compliance reasons, the solution should include both processed and raw data. The raw data does not need to be accessed regularly, but when needed, should be accessible within 24 hours. See, immediately I already know the answer just by looking at that. But what solution should the data engineer deploy? So read the question like I just did, right? And let's see if we can identify key phrases and qualifiers. Well, there they are. So this is the one that really pops out for me. Should be accessible within 24 hours. Because we basically said speed is not a concern. And cost effective is another one that pops out. And highly available, fine. You know, all of our services are highly available, so that doesn't really narrow down anything. But for at least 1 year means that we can't use like a stream or something to host our data, right? So you should already be thinking cold storage, frozen storage, you know, really cold, not warm, not hot. So what's the coldest thing we've got? Well, all right, let's read through the options. So, so we're gonna eliminate answers first. So let's look at these questions, or sorry, these answers. We can use S3 standard for raw data, Glacier Deep Archive. Oh, there's the cold part. For all processed data. Okay, so that's interesting. Use S3 standard for processed data. That's within 1 year processing. After 1 year, use Glacier for processed data. Use Deep Archive for all raw data. Okay. How about EFS for processed data? that's within 1 year of processing. Within 1 year, move over to S3. Or S3D, use S3 standard for both raw process data. After 1 year, go to Glacier. So, yeah, what can we eliminate? Well, S3 standard for raw data is not cost effective, right? We don't need to actually have access to raw data. Well, it says within 24 hours. So S3 is a little bit overkill for that. So there's this option that says S3 standard for raw data, so maybe we don't like that. That's supposed to go through answer A here. And EFS is even more expensive and more online. So again, this is supposed to go through question C, answer C here. Sorry about that. And then that leaves us with B and D as options. And B, which is S3 standard for process data, is within 1 year processing. After 1 year, use Glacier. So whereas D is S3 standard for both raw and process data. So it seems to me like I would go, standard is cheaper than EFS, so we got rid of EFS. Okay, so that's just kind of all over the place. But of these options, we would want to go with, S3 standard for process data that's within 1 year of processing. After 1 year, use Glacier for the process data. Use Deep Archive for all raw data. Yeah, so I would go with B. Okay, so that's the one that we would end up with, and D should also be crossed out. Okay, so B will give us the most cost-effective option, right? What about this? An ad tech company has hired a data engineer to create, maintain machine learning pipeline for its clickstream data. Data will be gathered from various sources, including on-prem, and will need to be streamed to the company's EMR instances for further processing. Which service or combination of services can the company use to meet these requirements? So again, we take a step back. The key words here would be from various sources, including on-prem and streaming, right? And we've already given you EMR. We said, hey, you're using Hadoop, right? Possibly Spark within Hadoop. So here are the answers, the possible answers. Well, we heard the word streaming, right? There it is. And, there is a thing called DynamoDB streams, but let's see if we can eliminate things here. So DynamoDB streams does exist, but, now we're adding an extra piece to our options. So what can we eliminate? We can eliminate A. So A is Kinesis data streams to stream the data, Kinesis Firehose to deliver data to S3, right? So the problem here is that actually this should be C that we're eliminating first. C as well. So DynamoDB streams, I think I already said. So we're going to get rid of DynamoDB streams because that doesn't really, it just adds more complication to the mix, right? So basically eliminate the obvious wrong answers. A is obviously wrong because the service, so Kinesis data streams, data firehose is used for ingest data into a service like S3, but not to read the data, right? So we're trying to read the data here, right? So we need to figure out what we're going to use to fetch the data, not what we're using to store the data. So we get rid of A, we get rid of C. So see if we got the animations there. And lastly, we might be able to get rid of D as well. So why? Well, we don't use the KPL to read, right? The client is what does the reading. The producer is what writes into a stream. So again, your knowledge of Kinesis would be helpful here. So Kinesis producer library, think it produces messages into Kinesis data streams. The client library is a reader from the stream, right? So you got data sitting in the stream. We use the client to pull data out. So since the question is asking us to fetch data or read data from the stream so that we can use it and then push it into EMR, it's the KCL that will be used in our code to actually read from the stream, right? Oh, and by the way, you'll notice that you have to choose either Kinesis or DynamoDB. Remember, we're quite proud of Kinesis, right? So Kafka is not an option here, and so on, right? Okay, so that actually gets us to our first little 5-minute quiz. So we walked through a couple of questions here, but what we really want to do, and I think what you guys are definitely waiting for, and I hope this is exciting for you, is that we have little small exams for you to take along the way, and this is the first of them. So just bear with me here. I just have to copy and paste this out of Microsoft Word, which is all right. So what we're going to do is I'm going to paste the link into the chat. Okay, so hopefully you guys all have found where the chat is in the interface. And obviously you can't click my screen to begin. Okay, so don't try to click the screen. It's not going to work. So what I will do is I'll prepare a timer here. That's only 5 minutes. Okay, so it's 5-minute quiz. Please take 3 minutes for the 3 questions that we're about to give you, and then try to answer them quickly. 1 minute per question, 3 minutes in total, 3 questions, and then what you can do is take another couple minutes afterwards. You'll actually see the result. Okay, so we'll show you which questions you got right, which questions you got wrong. I know you're going to get all 3 of them right, but if you did get one wrong, on the off chance, then you can take some time to to think about it for a couple minutes, and also do a bit of research on that and see how you feel about that. But again, remember, the goal here is to help you identify where your weaknesses are, not actually to teach the material. So let me just paste this link here. So quiz 1 can be found here. And as soon as I send this to you, I will also start a timer for 5 minutes. That's the time you have to take a look at this quiz. Just bear with me. It's not pasting properly. Let's put angle brackets in there and all kinds of fun stuff. All right. So let me just kick that off. There's the link. And here's your 5 minutes. I will be muted while you take this quiz. Okay, so we're just shy of 10 seconds here. I hope that you had some fun with those 3 questions. And of course, this link that I just gave you here is a link you can use again in the future if you want to see those same 3 questions again. They won't change, so it's not like you get another 3 questions. But those 3 questions are a pretty good representation of what you would expect to get. All right, so. Okay, so let's take a look at the next domain. So that was the first domain, which was data engineering. Second, and that was worth 20% of your exam, right? Second domain, exploratory data analysis. Notice how we're starting off with the tail ends of the pipeline, right? So first we're talking about getting data into the lake so that it's ready to be trained on. And now we're talking about the other end where we're looking at what a human would do. So this is where we say, hey, don't just dive deep into machine learning. Sometimes it's good to take a look at your data first. Before you start creating a recipe, look at the tomato, right? Look at what you're about to slice up and cook with, right? Everybody wants to be that chef that comes up with the next awesome recipe. But if you're not paying attention to your ingredients, well, you might potentially end up with really bad output, right? So all we're saying here is take some time, and we feel 24% of your exam time, to think about cleaning the data, preparing the data. What does it even mean? So back to my tomato example. Let's say in your garden you've planted some tomatoes or some celery, or celery is a kind of boring vegetable, but you get the idea. You plant some stuff, and now you need to clean it, right? Usually we clean our vegetables before we cook with them, right? So we need to prepare this data before we can model with it. Yeah, we talk about feature engineering. So again, if we're using cooking as an analogy, this would be like slicing it up. Do you slice the tomato or do you crush the tomato? What do you do with it? And that will depend on what you're going to do with that ingredient, that data, eventually. So we'll talk about the concepts you need to know in this space. And then actually look at the data. I mean, honestly, I think 2.3 is the first thing I do, right? Whenever I get handed a bunch of data, I want to open it up in Excel. Yes, I said Excel, or some kind of spreadsheet, and just quickly slice and dice it, show myself a pie chart like this. I mean, look, this looks like Pac-Man, right? It's kind of mostly open, but if it's really closed, then that means there's less of a wedge, right? This gives me a sense of how important this data might be to my model. Maybe I might just exclude it, right? I can save some time, maybe things like that. So first thing to do, sanitize, prepare data for modeling. Data is ingested, transformed, but still messy and misunderstood. What do we mean by that? Well, you need to know what your data is, right? Don't just throw it at your model and hope that it works. I mean, that's kind of, well, yeah, it's just being really brute force, right? So you want to practice your stats 101 skills here, right? Actually look at the data, maybe do an ANOVA table on it, do some multivariate stats on this, and get a sense of what it looks like. And I think one of the best ways is to just count the data. Okay, how big is your data? Do you have 3 samples or do you have 3 billion samples? It's a very different thing. So there's a number of instances. That's the fancy word that statisticians like to use to represent the observations that are made. So we have, let's say, 100 observations, 100 customers and what they purchased, right? Those would be your instances. But then what do we know about what they purchased? Well, how much did they spend? That could be an attribute. Where do they live? That could be another attribute. Things like that, right? So we want to go through and look at the attributes themselves, right? You do simple calculations like averages, variance, like I said, possibly an ANOVA table, and maybe visualize it using various statistical techniques, right? Don't forget basic stats is all we're saying here. So you might be dealing with categorical data. So for instance, here we have some examples of categorical data, and just be aware that you might have some imbalances. So look at least frequent here. we've got empties along with the number 1. Under most frequent, we have, yeah. Oh, sorry. So we're looking at, my apologies. So we're looking at the variables, right? So we got transaction ID. There's 45,000 unique values for transaction ID, right? And that totally doesn't make any sense. Transaction ID is probably a unique value that has no significance with respect to our sample. Education, there's 5 unique values. The most frequent one is secondary. That's just high school, basically. Transaction amount, unique values is, well, again, it looks like many of our transactions are of different amounts. The most frequent was $6.39. So there might be an item that is $6.39 that is sold often. There's 86 different ages, and most frequent is 43, and so on. So we're basically going through and looking at each of these variables and doing some basic descriptions on it. So looking for imbalances, looking for skew, that sort of thing. But this is not really a good way to visualize your data. We're going to look at some better ideas like histograms and whatnot in a second. So correlations. Yeah, correlations are really a big part of machine learning, right? So if you've got feature 1, okay, firstly, how do you read this? All we're doing here is we're calculating the correlation and then displaying it as a matrix of one feature versus another feature. So here, feature 0 is 100% correlated with feature 0, right? Every time a customer is a male, the customer is also a male. Okay, so as you can see, the diagonal here is 1.0 all the way. Okay, so we just generally ignore this. You know, this whole diagonal here it's obviously 1.0, right? But these other features here, look at feature 2 versus feature 0, or feature 3 versus feature 2, or feature 2 versus feature 3. Notice that these two, of course, will be the same. These two will be the same. These are actually the same thing, right? 2 to 0 and 0 to 2 work out the same, right? So, but here we have 100% correlation. Here we have almost 100% correlation. Here we have almost negative 100% correlation. So these features vary together or co-vary either negatively or positively together. And this might help us to identify dependent features. What I mean by dependent is, you know, these two features vary together, right? So this will play into the picture later on in this discussion. Another way to view this data would be to plot it out as scatter plots, right? So here you can see where we have positive correlation, right? This is positive correlation. You get almost a diagonal line that's sloping up, right? If it just looks like a mess, we don't really have a mess here. I guess this is kind of like a mess right here. Then that's more of an indication of loose correlation, right? Which means that those features are not really connected to each other. They're not dependent on each other. And there's they convey unique information to our model. So this is the same matrix from earlier. So here you're quantifying those linear relationships. So this is indicating that we've got, you know, a pretty straight line here, a pretty straight line here. This would be a perfect 45-degree diagonal line. This would be actually a line that goes like this, right? So it's negative 45 degrees, right? But still, that's what it would look like in the scatter plot, right? So I think a scatter plot is a much better way to visualize and to see, as a human, to see these patterns. And what are we going to do with those patterns? Well, you're going to clean with them, right? So a very big challenge that we have when training a model is that computers are not, they're kind of slow, right? I mean, yeah, they come a long way, but still, the more data that we give to train with, the longer it's going to take to execute. So what we might do as one step of cleaning is we might do some feature selection. We might say, well, you know what? These two features are positively correlated, so why do we need to explore both of them, right? You know, yeah. So let's take a look at some examples. Firstly, you might have this kind of thing going on. If we're talking about like free form text or something like that, you know, you might want to standardize this, right? Now, we're not saying that one language is dominant over another and you should pick that language or something like that. But what we mean is you do need to choose something to represent your data. Now, in this case, survey response, this is supposed to be just, it's just text, right? So we might engage in some other NLP or something on that. Here, you might also want to make sure the data is on the same scale. Here we have nanometers, inches, feet, meters, miles, meters, kilometers, right? So what's going on here? Let's see if we can turn this all into, I don't know, let's say centimeters or something like that. Yeah, make sure that a column doesn't actually include multiple features. So here we're saying, well, there's a length, there's a number of cats, there's a volumetric measurement. So what's going on here, right? So megabytes per second, that's a rate. So you might need to split this up into separate features or ask the question, where did this data come from? Like, is this somebody's open spreadsheet or what, right? So okay, so now here's the thing. You might have a relatively correlated couple of features, but you might have these outliers over here. Look at those. And those make me happy. They do. Outliers give me potentially information. It could just be noise, right? But they make me happy because then I'm like, wait a second. This could actually be like an indication of something. This could be the cure to cancer. This could be, COVID, right? Something like that. So maybe we've come across something that just is not the norm, right? And it can either be exceptionally good, it could be exceptionally bad. It could be, but the thing is, it's exceptional. It's something that's the except, right? It's the abnormal, right? So that abnormal can be celebrated in the sense that this is something we might actually want to pay attention to. And then it causes us to ask more questions. Notice we haven't started with any machine learning yet. We're just doing basic stats on this. And we're like, the richness that this could add to our data. We might say, well, let's take this out and turn this into its own feature. We might turn this into its own attribute and say, whenever the sample has a negativeness or a positiveness that is so exceptional compared to the norm, then let's call that the feature X, right? This is the thing we want to explore more. So you would only discover that by visualizing, I think, although you can use, stats to figure this out too. And the thing is, when you're collecting data, in the real world, you will have nulls, okay? Like people do opt out of providing information. They do, right? Like I'm sure most of us, we see an option, we're like, oh yeah, I agree, and I let vendor X do whatever they want with my data. But there are people who will say, no, I don't want you to have my data, or I don't want you to use my data in this way. So what do? Or maybe we just didn't collect it, right? So you could impute the missing value just to help the training algorithm actually finish the computation. So there might need to be a value there. So you could just zero it. You could put a big 0 in there, or you could take the average of all of these data points and then put that in here. Or you might do some form of regression as well, like maybe pull up a linear regression and then impute the value from that. Okay. All right. So these are topics related to this subdomain. So data set generation using SageMaker Ground Truth. Oh, so that SageMaker Ground Truth can be used to create labeled data for your supervised learning. We haven't talked about that yet, but that's one of the goals of cleaning our data is to prepare it for use in our training process. You might even use humans. There's nothing wrong with humans, okay? Like I understand machine learning is commonly discussed in the context of artificial intelligence, but there's still value to real intelligence. Okay, so you might do some data augmentation. You might say, well, it's time to pull in other data from other sources. You definitely want to look at basic statistics, informative statistics, as well as deal with those missing values or possibly those outliers. Those could be very useful signals, or they might just be noise. I mean, it always gets me excited when I see those extreme values, and I'm like, oh, cool, maybe we've come across something that's really neat. What about feature engineering? So I talked about feature engineering already, but it's just taking the original attribute and turning it into something more powerful for your model, right? So it gives the model more predictive power, more strength. Well, what do we mean? Well, actually, let's go back a few slides here. There was this picture right here, right, where perhaps I turn these outliers into their own feature. I might turn this into a separate column. So I might do some pre-processing and say, okay, whenever I see, let's say I take my tomato again. All my tomatoes are usually round. You know, there's some that are really big, but they're all round and they're red. And when I look at the skin of the tomato, there's no like imperfections or whatever. That's perfect. But here we have some tomatoes with a hole in them. And here we have tomatoes with a hole in them as well. Like, you know, something has caused the hole in the tomato. Well, we could just throw the tomato away, or we might let it, I don't know, whatever created the hole might be living inside. Maybe it's a butterfly. I don't know. I'm not actually a biologist or whatever. I don't really know this stuff, but I'm just saying, you don't know what's really inside there. So the thing is, you might turn that into a separate feature. You might isolate those tomatoes and say, well, okay, these are not the average tomato. There's something special going on here. Let's hold it aside. Don't just toss it away. It is still data you collected. So let's turn that into its own feature. Let's engineer a feature out of it. Let's create a new feature from the original data. Be careful with engineering features though, because you could cause overfit. Now, I didn't create these slides, but this is awesome, right? Really, you have to ask your question. You have to ask, well, what do you use when you're using real intelligence? Like when you're crossing the street and you don't want to intersect with a fast-moving object, what do you use? Right? You might use your eyes, you might use your ears. These are senses that you might use to collect data from the environment so that you don't get hit by a moving truck, right? And not only that, you might engineer what you see. You already do this subconsciously. When you look at a street, you're about to cross the street, you're paying attention to other cars. If you see a cat walking around the street on the other side of the street, you ignore it, right? You do this naturally, and this is just something that human intelligence is able to figure out. We're like, but your eyes can still see it. You can still see the cat on the other side of the street, but you're ignoring it because the cat is less likely to attack you than a car, right? So, and you've kind of, and I bet you didn't learn this from experience. It's not like you got hit by 20 cars in the past, and then you eventually figured it out. Oh, I should not watch the cat, I should watch the cars. You're just like, well, I'm paying attention to the cars, right? I don't even think, I mean, your parents probably at some point suggested that you should pay attention to cars, but you probably didn't need to be told this, right? They look a little scary and stuff. And the funny thing is, I've never had a driver's license, so I have no clue what I'm talking about. But I still know how to cross the street and not get hit. So far, I've never been hit by a car or been in a car accident. And that's an outlier, actually, as a passenger. You know, anyhow, so feature engineering may be necessary because of your data's dimensionality. Ooh, there's a big fancy word, but dimensionality really just means that there's a lot of attributes. You see, look at this ... right here. You might be collecting hundreds, thousands of attributes. So if this was in a spreadsheet, there could be literally thousands of columns. So maybe they're not all useful. I mean, look at this. Lot size and bedrooms and area, like square footage of the house. These things are positively correlated. You cannot build a gigantic house on a very small lot. You cannot have 18 bedrooms in a 200 square foot lot. Okay, I'm just going to say that. And again, I realize different standards around the world, but still not to that extreme. So generally, area, bedrooms, and lot size co-vary. They vary together, right? And if you were to scatter plot this, you would probably see most of your points on like a straight line kind of thing, something like that. It's not going to be like, you know, this random cloud of dots. It's going to be more like this, right? So in those cases, you might use a tool like PCA or maybe a stochastic neighbor embedding approach to detect these covariances, right? And then you could reduce these three into one. You see, okay, going back to crossing the street, if I'm crossing the street and I have to process 1,000 different pieces of information, my brain would be overwhelmed. I'm not that smart. I cannot see the cat and the dog and all the cars and the trees across the street and the people around me talking about things and listening to their conversations and all that other stuff. I have to tune that stuff out, is what we're really saying. And the same thing happens with machine learning. You have to tune out too much information because you're going to overwhelm the machine learning, right? You're going to overwhelm the model. It just can't handle that many inputs. Or if you try to feed all that in, actually you might overemphasize these particular attributes, right? So, so for numerical features, what you can do is just do some transformation. So you might square or cube some data. You might multiply it. That's just, you know. You may want to convert categorical data into numerical data. Maybe the algorithm requires numbers for everything. So categories might be ordinal, or they might be nominal. Ordinal just means that there is an order that you can sort them in. Large is bigger than medium, which is bigger than small. Categories are just completely not ordered. We don't feel that purple is better than magenta. We don't feel that, what is that, teal is better than magenta. There's no order in which these colors really, you know, they really don't. There's no order to the colors, right? And that's a pretty fitting statement at the moment. So here is a piece of home mortgage data set. So it's used to predict whether or not you will be approved or not for a loan. This is our objective, okay? So our objective is to be able to predict whether or not you should be given a loan or not. And here are some actual instances. So here was a house that was 3 bedrooms, 2,500 square feet, garden size small, price was this, loan was approved, and so on. What's interesting about this is we don't have any information about the person who's taking the loan out, so I don't really know now. So you might need to turn the loan approved into ones and zeros because maybe your algorithm doesn't expect to see strings. That's all we're saying here, right? So we're just encoding yes and no to 0 and 1. Now, that's not to say that yes is more valuable than no. It's not ordinal, right? It's just a category. And here, these numerical features might need some feature engineering. So what do we mean by that? Well, we might want to turn it into some, like maybe combine that all into one feature so as to reduce the number of attributes that we're feeding into the training. Price tends to co-vary with area and number of bedrooms as well. Bigger the house, bigger the money, right? And garden size. Garden size, you know, we have small NA, large, medium NA. Well, it might be good to turn this into numbers as well, but since the actual strings do convey some order, meaning that large is bigger than small, right? Then we might want to assign numbers to this that actually convey that that size difference. Now, in this case, it's not ratio, meaning that it's not that large is twice as big as medium. We don't really know that, but we do know that large is bigger than medium, right? And then when you've got nominal variables like this, you know, don't encode them as numerical values. If you do that, then you give you run the risk of, well, with some algorithms, you run the risk of implying an ordinal status. So, you know, if you assign house to 1, apartment to 2, and condo to 3, we might be saying that condos are more valuable than apartments, which are more valuable than houses. And this could be very risky. This could be extremely bad if this happens to be something related to, let's say, gender or race or something like that, right? So you wouldn't want ordinality to be suddenly implied. So then use one hot encoding, right? So then house turns into its own column, apartment turns into its own column, condo turns into its own column, and we put a 1 in that column if it's a house. That's what one hot encoding means. So here we've got house, and then there is the column for house. So anytime it's a house, we put a 1 here. And then for this particular instance, it's a type of apartment. So every instance that is an apartment, we label it as a 1 here. So we're not saying that that house is better than condo, or apartment is better than condo, or anything like that. There's no implied order. It's just, is this thing a condo? Yes or no. Is this thing an apartment? Yes or no. Now, this looks really wasteful. Like if you're coming from a database background, you're going to say, this is awful. We've just denormalized our data and we have all these zeros wasting disk space. But that's not the point. Our goal here is not to save disk space. Our goal is to engineer the features so that it can be fed into an algorithm. So what about the price? So we might need to scale this so as to get more meaning out of this. So numerical data can be scaled and so that we have proportionate influence on the prediction. So what do we mean by that? Well, we've got some prices that are very low and some prices that are very high. We might need to scale those back in, or we might need to eliminate these outliers. It's possible. So when we're analyzing economically, we do have outliers. An example would be Warren Buffett. He makes a little bit more than I do, right? So there is an outlier. There aren't very many in that category, right? So we might not want the model to model the unusual because they're the unusual, right? So, you might scale using min-max or max absolute value, or you might use a normalizer, that sort of thing. Okay, so these are all kinds of terms. These are terms of different techniques that you definitely want to be familiar with before this exam. Okay, finally, analyze, visualize data for machine learning. So when you visualize, you might notice that, let's say all the calls that you're getting at a call center, a big chunk of them come from New York. So then you might say, hey, wait a second, you know, maybe instead of just tracking the number of calls globally, maybe we should actually look at tracking the feature. So let's group each of our items, each of our instances by city as well. Let's add a city attribute, and that attribute then becomes a feature. So the term feature and attribute we tend to use interchangeably. Attribute is the data we've collected. Feature is something we're explicitly choosing to train the model with. That's all, right? So you might do a density plot, histogram, box plot. These are all basic statistics. So a scatter plot could show a relationship. So here we have a linear relationship, but notice that when we get high enough, it actually degrades, right? So that's interesting. You know, you might want to explore that some more. Histogram shows, in this case, a fairly normal distribution with skewness, right? In this case, we're skewed to, this is actually right skewed, even though the clump is to the left. In other words, the tail goes to the right. So again, be familiar with the different plots, know what a scatter plot is, know what a box plot is, and know when to use them. Okay, this is on the exam. I'm just gonna say that very point blank right now. Okay, so this is, you know, so be familiar with these different plots, be familiar with what kind of information they convey, so that if, you know, you're asked to say, well, which one of these would show you an outlier, you would know that, you know, possibly scatter would come to mind, a scatter matrix maybe, although if it's really just an outlier in a single variable or a single attribute, you don't really need to do a full matrix. So, yeah, so just know that. Then what about confusion matrix? So we'll talk about that later as well. All right, let's go through a few questions really quickly, and then we'll take a break for a quiz, another quiz coming up. So a team of data scientists in a company focusing on security and smart home devices created an ML model to classify guest types at front door using video door bell. The team is getting an accuracy of 96% on validation data set. However, when the team tested this model in production, images were classified with a much lower accuracy. This was due to weather. The changing seasons had an impact on the quality of production images. What can we do to improve the model? So again, before we even look at the answers, let's pick out the key words here, right? Well, our objective is to classify guest types. You know, is this a robber, a thief, or an Amazon delivery guy, or why did I say guy? Delivery person, and so on, right? So, but hey, we're getting lower accuracy. than what we got when we did testing against the validation data set. So when I look at this, I already kind of can write the answer. You know, I already kind of know. But let's look at the answers that were given. So we have to choose from one of these. We can use data augmentation techniques to add more images so model can generalize better. We could normalize the data set so that the features are on the same scale to help with convergence. We could give the model more time to train so it learns the key features more effectively. We could use different CNN algorithm that will give better model accuracy. Well, going back to the question, I immediately see a problem. You know, it's like, look, we're getting amazing accuracy when we validate, right? This is offline. But then when we go to prod, it's horrible. So what's going on here? Well, the things that really pop out to me as bad choices would be like, you know, do any of these, you know, choices really kind of pop out as not being super related to preparing the data set? So give the model more time to train so it learns key features more effectively. Well, that's just waiting longer and actually possibly overfitting more. So I don't really like C. And what about D? Use a different convolutional neural network algorithm that will give a better model accuracy. Well, we're not having problems with accuracy. We're getting extraordinary accuracy, so that's not really going to help me here too. The problem is my accuracy is on the validation data set. I'm actually potentially overfitting, so this is only going to potentially give me the same results. So I don't like C or D. So those lines are supposed to go through C and D. So that leaves us with A and B. So we don't like C, we don't like D, so we're down to A and B. Use data augmentation techniques to add more images. So yeah, so we can either add more images or we can normalize the data set so the features are on the same scale to help with convergence. So again, the thing is, what do we do here? Well, if we normalize the data set, all we're going to do is probably increase the fit, right? Now, if you're not able to follow this, by the way, then you need to learn a little more machine learning, right? This is all sort of, remember, this is a 300 level exam. So our goal is to show you where you're lacking, right? So and then that way you know what to study, right? So so if we normalize the data set so the features are on the same scale, like B here, this is also coming to question for me. I'm not liking B because, well, all I'm going to do is further fit the data. I'm just fitting, right? So really, this question says to me, overfit. That's the thing that really comes to mind here. But we're diving a little too deep here. Point is, the answer is A. Okay, so you need more data. You need more noise, actually. So you might deliberately noise up the images. And again, you would learn this when you're, looking at image processing. So these lines are supposed to go through B, C, and D. Okay, A is the answer in that case. Here's an example. A team of data scientists in a financial company wants to predict the risk for its incoming customer loan applications. Team has decided to do this by applying XGBoost algo, which will predict the probability that a customer will default on a loan. In order to create this solution, team wants to first merge the customer application data with demographic and location data before feeding it into the model. However, the dimension of this data is really large, and the team wants to keep only those features that are most relevant to the prediction. All right, so this sounds like dimensionality reduction, right? And why? Well, okay, fine, they picked an algo. Doesn't really matter, actually, but we've highlighted it because that's what we use, right? And then merge the customer application data with demographic and location data. In other words, we want to do some PCA possibly to combine those. Remember I was saying we have too many features we're trying to observe. We want to pare this down, right? So the dimensionality of this data is really large. We even tell you right there that there's too many columns. The spreadsheet is too wide. How do we make it more narrow? We want to narrow down the features, bring it down so it's fewer. So what techniques can we use? Well, you could use dropout to remove some of the columns during training. You could use T-distributed stochastic neighbor embedding. You could use clustering to find salient clusters and use those as features. In other words, engineer a new feature out. You could use PCA. Gee, I think I already said PCA earlier, right? So I was already anticipating the answer based on, of course, my knowing ML, right? So use AWS Glue Tokenizer to automatically. No, that's not what Tokenizer does. So the thing is, there's distractors in here, right? So you just need to know what these things are. So Tokenizer has nothing to do with, yeah, it's got nothing to do with this, right? So that's not really going to drop irrelevant features. It's just going to turn features into tokens. So that doesn't help me. Now, if you don't know what Tokenizer is, you got to go to the documentation for Glue, right? Remember, we're not teaching you Glue here, right? So that's E. These slides are all wonky. They were good yesterday. All right, so E is out. All right, and then so E is out, and what about clustering? Define salient clusters, use them as features. Not sure I like that one either. So why? Well, because we're adding more features. Right? We're engineering yet a new feature when the whole problem is we already have too many features. So you're going in the wrong direction here. We told you we're trying to reduce the dimensionality. It's too large. We want to reduce dimensionality, not increase it. So C would increase dimensionality, so get rid of that. And A, use dropout to remove some of the columns during training. Well, yeah, but dropout is more to randomize the training. So you might use this for, you know, we use dropout when we are getting overfit. So it's like saying, oh, we've learned that only cars can hit us, so let's start ignoring cars, right? We're overfit there because, in fact, it turns out the cat could attack us. So we get rid of that. And just through a process of elimination, we're down to B and D. And actually, I've already, before even showing the answer, said PCA. So PCA is one approach you can use for dimensionality reduction, specifically for that. And then also T, distributed stochastic neighbor embedding, does exactly the same thing. So we're taking multiple features, combining them into one. So that will reduce the number of columns in that in those slides. Okay, so all right, so let's take a look at the next quiz. We've got another 3 questions lined up for you, and I hope you guys are enjoying that at least. I just want to remind you that this course is not designed to teach you the concepts. That is not what we're doing here. We are here to look at the exam, right? And how you will do on the exam. So if you're finding that this material is way beyond what you thought it would be, then that's a pretty strong indicator that you've got a bit to learn, and we're giving you the topics that you're going to have to go study. We'll give you some resources later as well on how to, you know, where to find this kind of information and whatnot, so you can actually do some studying. But don't take this exam lightly. Okay, so all right, so let's take a look at quiz 2. We'll do that really fast. Let me just paste that correctly because, again, just bear with me. So just like earlier, we'll be pasting this into the chat. And I'll give you guys 5 minutes, 3 minutes for the 3 questions, and then 2 more minutes for you to review and to see how you felt about this. Okay. There you go. There's the timer. Oops. Okay, so we've got a few seconds left here, and all right. So this one of the questions. So like I said, we've actually got 3 other esteemed colleagues in the room handling questions. Joe, Chris, and Darren. You know, very seasoned trainers as well. And one question was sort of brought to my attention, which is great. So with one of the examples that we had earlier, there weren't, I would agree with the statement that's being made by the participant here. So that when we looked at this sample question, you know, these 2 options are not necessarily the best way to solve this problem of high dimensionality, right? But you don't want to argue with the exam, right? So agreed that the exam might not be how you would solve the problem, but the question is, of these choices, which 2 options would best get you towards this goal if you were in this situation? Because your goal here is to pass the exam, not correct the exam. And I understand, by the way, this is one of the hardest things for me when I'm taking an exam. You know, where I feel like, okay, whoever created this question, you know, I don't know if I would agree with any of these answers. That's not a good way to pass the exam. Okay, so remember, that is the goal of this session, is to help you identify where your weaknesses are. And my weakness tends to be, I actually feel that, especially when I'm putting on my philosopher hat, which by the way is what I did my undergrad in, I like to argue and I like to find the corner cases. And that's what makes you very strong in your field, actually. This is what makes you a very amazing data scientist. But on an exam, sometimes what we're trying to test for is not necessarily that can you come up with a brilliant solution, but it's, of these possible solutions, which would you take, right? And that's really, I think, another key point to surviving the exam. All right. So now we need to jump into our 3rd domain. Remember, this is 3 hours, very tightly packed, a lot of domains to cover. And the takeaway from this, from these 3 hours, is the domains. Know what the breadth of the exam is. We're not trying to cover the material, right? If you have a deficiency in any of this, that's a strong indication that you got to go study more, right? So that's and we've got classes for that. We have free resources. We will be sending out, like I said, a list of resources after the seminar is over. So modeling is the biggest part of the exam, right? It's 36% of the exam, and modeling is what most people think of as machine learning, right? Like, it's where we spend most of our time studying. When I was going in grad school years ago, you know, we spent a lot of time doing proofs and maths, and that's really what we think of as machine learning. But it's so as you can see here, this is a big part of the exam. So let's look at each of these subdomains. So first, framing business problems as machine learning problems. This is a fairly quick one, because you need to think about, is machine learning even appropriate? You know, jumping into machine learning right off the bat might be overkill, right? So you kind of want to watch out for that. Now, if for purposes of this exam, you know, you do need to know how to filter out appropriate use cases for machine learning. So if you're given something that's relatively simple, then just avoid ML altogether. That is a valid answer. Okay, like, you know, sometimes it's just not appropriate. So if a simple regression will work, then just do that. So a good use case for mining data on credit card transactions is to predict fraud, right? So you're mining some data, you build a model on this. The patterns in the data could be complicated to identify on your own. So then, you know, that's where machine learning might be appropriate. Whereas if it's something like, oh, well, the larger the house, the more expensive the house, then maybe a simple linear regression might be sufficient for that. So the boundary, again, we can get philosophical about this, but that's not our goal, right? You know, where's the boundary between machine learning versus just basic statistics? And then where's the boundary between statistics and mathematics? And if you're interested in that debate, there's universities, you can go do your PhD in that. But it's not, that's not what the exam is aimed at. So machine learning is not a solution for every type of problem. Be able to identify a simple problem. And where you have a simple problem that can follow simple heuristics, walk away from machine learning. Okay, so that is the correct answer. Actually, forget about the exam. It's just generally the correct answer. So there's 3 categories of machine learning algorithms. We're going to break it down into supervised, unsupervised, and reinforcement learning. And again, we could debate about this for years if we wanted to really get academic about it. But let's just pick these 3 categories. So with supervised algorithms, we might be doing something like training, right? So, well, no, we are going to be doing training, but we need training data that's labeled, okay? So you must supply labels. A human must say, this is a cat, right? And this labeled data is used to actually train the model, through some process of an algorithm, some iterative process, right? And the output would be some kind of a model that we can then use to do predictions. So once the model is formed or has been fit, then we can use this to predict labels. Unsupervised algorithms discover patterns without pre-labeling our training data. Okay, so basically the data is fed into ML model fed into algorithm that pumps out a model, and then we basically have a couple of classifications that come out in this case. So the labels that we're giving here were given after the fact, right? A human looked at the clusters and said, oh, it looks like we're kind of grouping stuff either into small or large components or whatever. So supervised machine learning problems, they can be broken down into different types of objectives. So you might be trying to classify just a 0 or a 1, a true or a false. You might be trying to classify into multiple classes, more than 2, right? Or you might be trying to predict a number, right? So regression tends to be that. So you need to know when to choose a binary classifier versus a multi-class classifier versus a regression. So with binary classification, you're really talking about 2 possible outcomes. Either this is positively fraud or this is negatively not fraud, right? Or multi-class is just, well, kind of like binary classification, except we have more than 2 classifications, right? But then with regression, we're trying to predict some kind of number, a continuous value. So what will be the value of this house given these inputs? Given the number of bedrooms, given the number of toilets, given the number of all that stuff, the features that we feed in, give me a prediction of a number. Don't just tell me yes or no, tell me, like, what is the value of this house, right? So that's a regression. So reframe your business problem into an ML problem. So don't just get all academic and get all mathy on us, right? Like that's really just a bad service to your client, right? You need to understand what they're trying to do. That's also important in this domain, this subdomain. So how do you define the problem, or how you define the problem depends on the use case. You really need to drive this from what the business wants, and most businesses want profit, right? So if the target is numeric and it's a regression problem, then it might be framed as something like predict the number of purchases for each product. Number, that's a key word there, right? Number. Okay, so or if it's a classification problem, like predict which products will get more than X purchases. That's kind of reframing it, right? We're saying, well, are we trying to predict the actual number of sales of a product? Are we trying to predict high and low sales? And let's say we say more than 10 purchases is considered to be a large number of purchases. I don't know, right? So the thing is, you have to ask yourself, well, what does the business really want to identify? And many times the business has no idea, right? I have an MBA, and I remember when I did my MBA, we were not, it's pretty high level, as in like we don't get into details, and it's difficult sometimes to tease the actual desire out of the business or out of your client when you're coming from a more technical background. So just keep that in mind when you're going through questions. So if you see something that's misaligned with the actual algorithm you've chosen, choose the one that gives the most value for your business. Okay, always keep that in mind. All right, don't just jump into it and go, well, this is technically better. Yeah, but CFOs don't care about that. right? I've never been in a boardroom meeting where, you know, a CFO says, "Oh, did you use a stochastic gradient descent to maximize the throughput of this train?" No, they don't care. They just want to know, did you do good? Right? That's the level of the conversations I've had. So from the business side, you know, in this subdomain, just be aware that there's many different algorithms you might choose to use, and be familiar with each of these. Okay, so as you can see, there's a pretty long list here. Okay, so be familiar with you know, some deep learning and computer vision. Be familiar with the use cases for these. If somebody says convolutional neural network, you know what that's all about, and you generally have an intuition. Remember, that's one of our goals here, is that you have an intuition of what a CNN is. What's the architecture of that neural network? Maybe you can name certain ones, like ResNet, right? And so on. And then we have our more basic algorithms up here, right? So, all right. What about selecting appropriate models for a given problem? So this is what most of us focus on, right? We're like, hey, we have a problem, we framed it well, we think the business is very articulate, so we've got an actual problem we need to solve. So now what algo do you pick? Well, I think a lot of people spend a lot of energy studying this when they study machine learning. So you should have no problems with this, right? Like, you know, that's like the first thing we always do. We dive into that and we forget all the other stuff like cleaning data and stuff like that, because that's not fun, right? Nobody enjoys cleaning tomatoes. They just want to invent new recipes. So here's a scenario. You have a marketing manager. Those are the best, right? Want to conduct a direct mail campaign to attract new customers. All they know is they want more customers, right? That's the business problem. Get more customers. It's not choose the right algorithm or whatever. So, but really, you need to reframe this into a question of, well, okay, what this person is really saying is the direct mail campaign needs to be targeted to customers that will likely be responsive. So based on past customer responses, should I mail this customer? Yes or no? So now you can say, okay, fine, I need to choose some kind of model that will eventually output a 0 or a 1. Either yes, we do email this person, or no, we do not email this customer. So, or maybe you decide that you know, you want to actually decide what kind of customer this is. So you're trying to figure out, well, maybe we only want to attract wealthy customers, or maybe we want to attract customers that have been impacted by COVID economically, or whatever, right? So basically, we want to classify into more than one class, more than two classes, I should say, right? So which is not so obvious in this example here, but maybe empty nesters, urban professionals, students, and so on, right? There could be a very long list of different classes. So SageMaker to the rescue, right? If you find yourself wanting to use any one of these state-of-the-art algorithms, they're already built into SageMaker. We have them already built in. So we have a linear learner, XGBoost, K-nearest, neighbors, and a whole bunch of others. This is not a complete list. Once again, you need to go and learn SageMaker, right? So, or maybe you're trying to figure out value. So I find MBAs love to do this ROI thing. They love to show, hey, look, what I did was I brought all this money in. And these calculations are to produce an actual dollar value, right? Like what was the value of this campaign? What is the potential value of this campaign? So a regression would give me a number as an output, right? Again, this is fairly basic stuff. So SageMaker has a whole bunch of built-in algorithms, like I said. There's just 3 of them, right? Linear learner, you set a hyperparameter to the regressor. XGBoost set objective hyperparameter to rectify linear. Or you might decide with K nearest neighbors, maybe you query for K closest points and you just choose K, right? How many classes do you think you're going to have? Maybe you think you might have 5 different classes or 7 different classes. So how do you pick a hyperparameter? We'll get to that later. You also need to be familiar with the state-of-the-art NLP algorithms, at least just know them intuitively, okay? Like we're not looking for PhDs here. We're looking for you to at least be able to describe what blazing text is, how you would do sequence to sequencing. So you got a string of text and you're trying to, you know, boil that down into some kind of vector, right? So, and be familiar with computer vision. So be familiar with the, just familiar with, right? You don't have to be able to do a proof. This is not that kind of exam, right? But we definitely want to say, hey, look, if you have a computer vision problem, would ResNet solve this, or would you use a binary classifier, right? Or is it a combination of ResNet with a binary classifier? So choosing a training algorithm, think about the built-in algorithms for SageMaker. Be familiar with that list, okay? At least go through the list of SageMaker built-in algos. We've only listed, I think, about 10 here in these slides so far, but go to the documentation and actually learn it. It's pretty hard to pass an exam if you don't actually take the time to learn this stuff, right? So, and that is not what these 3 hours are, right? We're not cramming a year of experience into 3 hours. So be aware of that, right? So hopefully as we're going through this is all making sense. You're following this at this level of conversation. Remember that you can use TensorFlow or MixNet to construct your own models and have SageMaker construct the container for you. Or you can bring your own custom container. And notice I'm saying container because you should be familiar with SageMaker training service as actually really an orchestrator for Docker images. So we're starting to bridge the gap into operations now. Or you can even, don't forget that we have third-party marketplace. So Intel has, and a number of different vendors have images available for you to use on the marketplace. And some of them are free, some of them you pay as you go. But the point is that there's a single place you can go to pick other algorithms or other images that have been built by third parties that have been tuned in certain ways to solve certain problems. Now, you don't have to memorize the entire marketplace, obviously, but you should be familiar with SageMaker because that's our service for making it easy for you to construct this entire pipeline. So this laundry list of different algos, be familiar with them from a high level and within the context of SageMaker. Okay, so you definitely want to have worked with them at some point, at least try out the demos. Okay, so, this is not, I don't want to encourage diluting the certification. Okay, so, so then now that you've selected a model to use, or an algorithm to use, I should say, then you need to train the model, right? So you actually use an algorithm for training a model, to be very specific about the terminology. So, and it's an iterative process, right? Like when you first train a model, you're teaching it for the first time, it might perform poorly. So, yeah. Okay, so split data up into a proper division. So make sure you take your training set, break it up into pieces. I think we're getting some comments in the questions here that are diving a little bit too deep. Again, remember, the goal here is to focus on what you will see on the exam and strategies to do well on the exam, not to demonstrate that you're smarter than the exam. You only want to be as smart as the exam, okay? So indeed, some of you could, in fact, author your own exam. Just keep that in mind. That's one of the things that you have to battle when you're taking these exams is you might actually be smarter than the exam. Good. We want you to be certified. That's kind of the point, right? So anyhow, so the test set, the validation set, hold aside some data so that you actually have, you're not actually training with it, right? You don't want to show the algorithm the answers to what you're going to validate with. So training set is what you actually use to train the model, right? Validation is what you're using to give you an estimate of how well this model will perform in real life. But again, you have to watch out for overfit and stuff like that. And then the testing set is like a special set of data you hold aside completely that you never show to the training process, and you use this to literally quiz, so to speak, the actual the model to see how well it's going to perform. So cross-validation is one technique that you certainly should be familiar with. This is the idea of taking multiple models and testing them to see how well they're performing with respect to accuracy. So K-fold cross-validation is where you hold aside one part of your data, and then you hold aside a different part of the data, a different part of the data, and so on. And you train up let's say five examples here. Let's say we're holding 20% in each case. But what the benefit is with k-fold cross-validation is that we actually get a chance to train with 100% of our data, but also to see which of these, well, yeah, we say over here, we just average the results. Again, we're oversimplifying this. If you have a deeper understanding of this may bother you, but the goal here is just to understand that you choose the K. You choose how many folds you want to do. So if you want 5 iterations, you would say K equals 5, do your K-fold cross-validation that way. Other cross-validation methods, leave out one cross-validation. So that's just saying just leave out, well, it's exactly what it sounds like, right? So you leave out one and stratified K-fold cross-validation for imbalanced data. So just keep in mind that cross-validation may increase the amount of time, well, no, it definitely increases the amount of time you spend on computation, because instead of just doing 1 pass, you're now doing 5 passes or whatever, right? So, and it may increase the accuracy of your model, may increase the accuracy of your model. It may also overfit your model. It all depends, again, on your input. So, so creating a training job in SageMaker. This is what we care about, right? So you've landed your training data into S3, and then you literally take a container, a Docker image, right, which SageMaker will orchestrate through SageMaker Training. So SageMaker Training is a sub feature or a sub functionality of the SageMaker service, which basically orchestrates your EC2s for you. Right? You can ask SageMaker, hey, build a cluster of 6 nodes of this instance type, and then run this Docker image in the training mode, okay? Then once you've done that, then you can publish, or rather SageMaker automatically pushes a copy of that Docker image into an ECR for you, right? So you use ECR to hold your Docker image, and then you can use that in production, which we haven't gotten to yet. That'll be the next domain. So if that was all completely foreign to you, then you may need to study SageMaker. And we do actually have a 1-day class called Practical Data Science on SageMaker, or with Amazon SageMaker. And specifically, we spend a whole day just talking about SageMaker. Not machine learning, not data science, just really SageMaker. So we expect you to bring your knowledge of data science and machine learning to the table, right? We're not, I mean, you go to regular school for that in most cases. Plus, we have a few refresher courses that we'll give as links later on in the day. So you need to know how to run training jobs using containers. You need to know how to build your own containers. So this is Docker now we're talking about here, right? So you just need to know it's possible. How about that, right? On the exam, we're not actually going to say, here's a Docker file with the source code. What do you think of this? Let's critique this Python. Let's critique this this R. That's not our. That's too deep, right? And don't forget we have. You need to know about this. We have instances that we're very proud of that include GPUs. Be familiar with it. Be familiar with elastic inference, the ability to attach GPUs on the fly to a running instance, right? This is important. This is the stuff that's actually related to AWS, right? Again, just general machine learning. It's great if you're a doctorate in stats, but we're not testing you at that level. We're not interested in that. We're interested in, can you actually practically use our services to effect a solution? Not can you write a new paper to show the world that, I mean, yeah, go do that. Go write a paper somewhere. You can do that too, right? So, and actually we absolutely applaud that. But that's not necessarily a strategy to doing well on the exam itself. So next subdomain, perform hyperparameter optimization. So how do we pick K equals 5? How did we know to pick K equals 5? Did I just randomly pick that from the sky, or did I have some intuition? Where did that come from? So, so we already talked about feature engineering earlier. Another thing you might do is you might try other algorithms. So if you have no clue what algorithm to use, you can just try them all and see which one seems to have predictive capacity. You can also, well, what we're going to talk about now is tuning the hyperparameters. Maybe 5 was not the right number. Maybe K should be 4, right? Maybe we should do 4 K-fold. Or maybe when we're doing our clustering, maybe we need to identify more clusters, right? So the goal is to find a model that generalizes well. We're not trying to fit every point, right? So an example of a hyperparameter that usually gets mistuned would be the learning rate. You know, I've run across a number of cases where people are interested in the most accurate model possible. But the reality is you don't want a model that looks like this, right? You don't want to hit every point here because it's not very generalized, right? Sure, it's very accurate because I've literally hit every point, but it's not very generalized, right? So, so how do you tune hyperparameters? One is you can just guess. Okay, I mean, yeah, you can just guess. You can just say, well, I don't know, I think it's 8. Okay, so it's 8. Oh, let's try 6 this time. Let's try 20. I don't know. Let's just pick some random numbers and see what happens. It doesn't matter, right? The computer's cheap. My time is expensive, so I'm just going to pick some random number and let it run. But you know, you might want to do a search. So what happens if I set the parameter to one parameter to 1, and let's say the alpha, the lambda to 1, right? What happens if I set it to 1 and 2? What happens if I set it to 1 and 3, 1 and 4, 1 and 5, 1 and 6? How about 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6, so on? Literally just try every permutation you can possibly do. This is called a grid search. Grid search is going to cost you a lot of time, right? Because you're basically constructing, you know, in this case, just varying 2 parameters. You're now constructing, what is this? 6 times 4, so 24 models. So you've multiplied your training time times 24. So if it already took you 1 day to train a model, now it's going to take you 24 days, almost a whole month. An alternative is you can go random. You can just say, try this, try this, try this, try this, I don't know, whatever, right? And then if we notice that this seems to be performing very well, then maybe we just narrow down our search to this area here, right? Maybe. So with grid search, we try every possible combination. It can be very expensive to do this. Whereas with random search, we're going to, you know, kind of just jump around and try to find something that performs well. So the thing is, with grid search, you're being a perfectionist. Just be aware of that. I'm not saying it's good or bad, but you need to factor this in when you're answering questions, right? You need to say, well, does the question say you need to get the training done in a short amount of time, or is perfection valued over timeliness, and is cost not a factor? I'm going to give you a hint. For the purpose of this exam, I don't think you're going to get any questions that say, we are willing to spend infinite dollars and infinite time to solve a simple problem. Because no business will ever say that to you. No client that we're hoping, once you're certified, you're going to help service, you're going to help serve your clients, right? No client is going to come to you and say, I have infinite dollars and infinite time to give you infinite space to search for one single solution, right? Like that's just not a thing. So we're not going to examine in that way. So just keep that in mind. All right, and again, that's the thing. I find, especially with machine learning, it tends to attract academics. I'm an academic. You know, I mean, philosophy is not a practical discipline, right? But we've got to rein that in, because your goal here is to pass this multiple choice, multiple selection exam, right? So, and the computer on the other end that's scoring your exam is not going to applaud you for your brilliance. It's either you got it, your answers match what the exam author thought the answer should be, or it doesn't. And you might think the exam author is wrong. You're entitled to that opinion. I've had that opinion many times when I'm taking exams, not AWS exams, because ours are awesome, but I mean, you know, exams. But that is not the place to have that argument, because unfortunately, it's not a human on the other end that will see your comments. Well, actually, you can write comments on the exams, but again, you're burning time, right? You only have 170 minutes. So, so you do need to know, you can, in SageMaker, we have a hyperparameter tuning job. And, you know, I'm going to do it. Let me just quickly show this to you. So if we go to console, let me just make this a bit bigger for you. Oops, not connect. We go to SageMaker. Right? We have all of these features under SageMaker. And a lot of people, they get confused. They think SageMaker is just one thing. It's the models. We have ground truth. That's under SageMaker. We have notebook instances. This is where you can author your actual your actual jobs, author your models and do testing very quickly. Training is what we're talking about here, and hyperparameter tuning jobs. This is the actual feature within SageMaker where you can actually do a grid search. You can do a random search, right? So you need to be familiar with this stuff. You have to have actually used these services. Don't just try to look at a few slides here and hope that you've memorized it well enough that you can go and regurgitate this on an exam. That is not the purpose of this. Remember, this is a 300 level exam. It's not an associate level. It's a specialty. So just keep that in mind. All right. So anyhow, know how to do this in SageMaker. All right. And the idea is we automate this for you rather than the human having to drive this process along. So basically, the hyperparameter tuning job will automatically parallelize the spinning up of a number of training jobs. And each of these training jobs will be automatically running on a cluster of your design. So you actually specify how much parallelism you want, how big of a cluster you want. Do you want GPU instances or just regular M5s, right? All of that is to your specification. And then you specify, well, how are you going to measure the goodness of the model you produce? I call it goodness because, yeah, there's so many different ways of measuring how good a model is. You know, is it area under the curve? Is it response operator characteristics? Is it, are we going to use precision or recall? We're going to talk about all those things in a brief moment here. So, so tuning hyperparameters, you really need to know that SageMaker has this. This is a feature of SageMaker to automate the drudgery out of your day. So that as a data scientist, working with machine learning, you don't have to spend your human time babysitting the search for good hyperparameters. You can literally brute force it with a grid search if you really wanted to. You're just going to be running a lot of compute on the side, but the cool thing is your human time is not wasted just sitting there watching this process. You can just kick it off with SageMaker and go back to your notebook and start coding up your next storm, you know? So, and the typical hyperparameters you might want to tune would be like momentum or learning rate, dropout. These are all going to be model specific. So again, you would need to dive into each of those different models that we talked about, those different algorithms, I should say, and be familiar with what can be tuned for each of them. Not everything has an activation function, right? That's more related to deep learning, to be honest. So then evaluating the models. So then how do we know if we're performing well? So we've produced this model, we've done a hyperparameter search, and we've generated a model. So then remember we held off some data for testing purposes. So now we run a test. We say, okay, if we just feed these instances into the model we produced, how accurate is it? So, you know, does it actually say that a cat is a cat and a dog is a dog and a car is a car? Or does it just completely get it wrong? Does it look at it, we show it a picture of a cat and it comes back and says giraffe, right? You know, that's wrong. So if we get correct predictions, this is usually what we're looking for, right? This is what we're looking for. This makes us really, really happy. Usually that's our goal. We usually want our models to predict correctly, right? But for classification, how do we articulate how well or not well the predictions are happening? Well, we might use a confusion matrix as a way to describe this. So let's say we've got data that you know is a cat, right? So we have an example of an actual cat and the model predicted a cat. This is a good thing, okay? This makes me happy. If I show a giraffe to the model, but then it predicts a cat, well, unfortunately, this is the wrong case. So wherever I'm drawing a sad face, this is our negative, right? And wherever we're drawing a happy face, this is a positive. Sorry, a true. So a true or a false, right? So this is true, this is a false. So we were hoping for a negative, but we actually got a false positive, right? So the model falsely labeled this as a positive. It labeled it as a cat when in fact it was not a cat. So our goal is to get more happy faces or more trues than falses. That's generally what our goal is, right? So a confusion matrix gives you a way to describe how well this model is truly performing. So our goal is to maximize this and this, right? These make me happy. Every time my model correctly identifies cats, I like that. And every time the model correctly identifies not cats, I'm also happy. So this is probably the most confusing part, is that we call this a true negative, but this is a good thing. These are good things. Okay, I want to know that I do have a malignant tumor or I have a benign tumor, right? Tell me that, right? But get it right, right? So be right about the negative and be right about the positive. But then we might, in some cases, incorrectly identify a negative or incorrectly identify a positive. And real world models will have some degree of false negatives and false positives. If you get 100% spread across these two, then you probably have an overfit model. Anyhow, we're getting into the critique of models here, and that's way beyond the scope of an exam prep, right? So these purple boxes that you see here, these filled in boxes, are desirable, right? So you might calculate accuracy by doing a simple calculation like this. You take these two percentages, add them up, and then divide them by the entire percentage. Now, this is kind of goofy, because if you look at this, true positive plus false negative plus true negative is the entire universe. So this will always be 100% as your denominator. So really all we're saying is you don't need to do this part. You just need to add your true positives to your true negatives, and those two percentages added up could be used as what we would call the accuracy, right? So, but you may also look at different ratios. You might say, well, how precise? What is the precision of these predictions? So this is saying, well, let's look at how many true positives I'm getting versus the whole space of positives. In other words, how many times am I getting false positives, right? So we want to know, well, is everything that I'm predicting a positive on actually a positive, right? So in this case, let's say it is predicting a malignant tumor. And predicting a malignant tumor is important because we want to catch cancer early on so that we can deal with it, right? So our goal is to, this is very important. So we want to have, but here's the thing. If we get a false positive where, let's say our model predicts that it is malignant and that causes surgery as a result, right? The risk of surgery on a healthy patient outweighs the benefit of, so that could be what you find, right? So it all depends on what your goal is. You need to ask yourself, well, what is the risk of having false positives? If it's very risky, if your exposure is really high, you might end up killing somebody, or you might end up, then you want to maximize precision usually, right? But the problem with high precision is that you're also going to miss a lot of true negatives, right? That's usually the case. It's always a trade-off. So then the other side would be recall. So the analogy I like to use would be, let's say my goal is to go fishing. I want to go catch salmon from the ocean. So if I want to catch every salmon in the ocean, then what I want to do is I want to maximize recall. I want to maximize getting all the positives I can, right? But the trade-off will be I'm going to have to use a net that is cast so wide that I'm going to also dredge up all kinds of stuff, other stuff from the ocean, unfortunately. I will probably snag a whale. I'll probably snag some missing parts of the MH370. I might grab all kinds of random stuff from the ocean, but hey, I'm going to get all the salmon as well. This sounds like a really evil thing to do, doesn't it? But that might be your goal. So maybe your goal is to recall all the positives you can, but as a result, you may also end up dredging up additional false positives as well. So you end up pulling in false positives, actually. That's what recall does for us. Whereas with precision, we're saying, look, I don't care if I only get a small percentage of the overall salmon out there, but everything I catch better be a salmon. I don't want to harm a dolphin. I don't want to harm a whale or whatever, right? So then I will use a much more targeted approach. So other metrics that you need to be familiar with for this exam would be the F1 score, which is another way of calculating this ratio. So this is another way of articulating the goodness of your model. And AUC, area under the curve. I mean, you're usually aiming for close to 1.0, but you know, this is just another way of articulating the compromise between precision and recall. And that's really what this is. If you understand it as a compromise between the two, then you're golden for the exam, right? You basically need to know, well, what do you prioritize for this model, right? So, all right. So be familiar with sum of squared errors. RMSE is very famous. It's missing from this list, but you probably want to know MAPE as well. Sensitivity versus specificity is another way to describe precision and recall, right? So you may have learned this in your statistics many years back as sensitivity and specificity. If you're into drug research or any of those types of things, you probably use those terms. If you've done engineering, you've definitely come across response operator curve. These all describe the same kind of ideas, right? So you just need to be familiar with the different words that we use to describe the same concepts. And, you know, yeah, be familiar with a little bit of deep learning as well, okay? So even though the exam is called machine learning, deep learning is a type of machine learning, right? So just be familiar with the very output layer being like a soft max or something like that. What does that even mean? So a classic example is using the MNIST data set and classifying digits, for instance, something like that. All right, let's walk through some questions. We've actually got still a lot of material to go through and we're running short on time. So we're gonna pick up the pace here just a bit. Oil and natural gas company is using machine learning to discover prime locations for drilling. Company has chosen SageMaker, as service for creating machine learning models. The data scientists are using notebook instances to actually develop the models. That's great. However, data scientists spend a long time waiting for training jobs to complete. Oh, so they're doing the training in the notebook itself, right? So company wants to improve this idle time to more effectively iterate on the models with minimal change to the code, enabling data scientists to quickly experiment with their models without having to wait for the training job to load and data to train the model. Wait for the training job and load the data to train the model. So what should we do? Well, we're trying to increase the efficiency of our data scientists. We don't want them babysitting training in their notebook. That's basically what these highlighted pieces say. And that allows them to more agilely experiment, right? That's what I read out of these highlighted parts. So what do we have? Well, so we're gonna use the same approach, the same strategy, right? So this is all about exam taking strategies. So we wanna do some elimination. So what can we get rid of? Well, we can possibly get rid of, let's see. So using the built-in algorithms, well, that doesn't make any sense because we just said that the data scientists are already using notebooks to create their own custom models, right? This is custom, right? We've hired data scientists. You want them to actually use their brains and come up with new models, right? So using the built-in algorithms kind of defeats that purpose. So yeah, they're there, but that's a good place to kind of start when you're just looking around. But now you want to get in there and build your own custom Docker images. So A is probably not a good choice. And then change the training job to use pipe mode to improve the time it takes to train the model. Okay, yeah. Even if you don't know what pipe mode is, like let's say you have no clue, right? You're like, what's pipe mode? Is that even a thing? Well, let's say it is. Okay, let's just say we don't have a clue about what pipe mode is. Don't get distracted. Remember, we have distractors in here as well. Who cares? You're not trying to improve the time it takes to train the model. You're trying to offload the training of the model so that it doesn't actually waste the data scientist's time at all, right? You're not trying to make it run faster in the notebook. Yeah, I mean, okay, that's one small step in the right direction, but a better choice would be, why don't we just run the training completely somewhere else? Why don't we send it off to some magical service that will take care of this for us? So I don't know if I like this C so much. I don't like C. I want to eliminate it, but let me look at the rest of the options. Okay, so when I'm doing this in the exam, I would say, well, what do? Oh, D, create the models on local laptop, then port the code over to use SageMaker. Yeah, so actually, sorry. Yeah, so no, I mean, I don't see how that would be helpful. I mean, that's, well, actually, it could be, but it depends on how you're going to use SageMaker. So as you can see, the answers to the possible answers to these questions can be a bit ambiguous, right? So let's look at what we eliminate first, right? So so A, we're just talking about which algorithms to use, right? So A, it doesn't really help us. And then B, so these lines are going through the wrong things, by the way. Use Amazon SageMaker estimators in local mode to train the models. Local mode means that we're actually doing the training locally on the system, right? So I'm not a fan of that either. So again, these lines are going through the wrong thing. It should be A and B that we've eliminated first, okay? So now we have, oh, sorry, not A and B. This is correct. So it's A and D. And then the next one we want to get rid of is the pike mode. So pike mode just doesn't really help us because, again, we're not trying to improve the time that it takes to train the model, right? So actually, local mode is what we're going after here. So the thing is, what local mode will do is we're doing some training, but it's not with the full training set, right? So we really just have like a small amount of data that we've loaded into the notebook, and we're going to do that. That would allow for iteration, but still training locally. Now, where I was going with this conversation is, personally, I would look at this and say, well, hang on, maybe, well, it's the fast iteration that maybe we're leaning towards the local mode. But I feel another thing to explore would be, of course, SageMaker training, right? Put this offline, allow the data scientists to pump out 10 or 20 different experiments, throw them all at SageMaker training, then go for a lunch, come back, and then take a look, right? But I think the thing that leans us towards iteration is two things. Firstly, we don't have SageMaker training as an option here, right? So again, this is an example of where even myself, I'm kind of battling this because I can think of an even better answer than this, right? Which is E, right? So, but the problem is we don't have an E. So of these options, what would give me the most effective solution? And that would be, let's just run in local mode. So we haven't, again, offlined it. We're still local to the notebook, but at least we're using the estimators that are already optimized to run in SageMaker locally in the notebook. Data scientist has trained an XGBoost model to classify internal documents for further inquiry, and now wants to evaluate the model's performance by looking at results visually. So what do we mean by this? So so we've trained an XGBoost model, right? And then we want to look at the performance visually, right? So what technique can we use? Well, let's again pick out the keywords. We're trying to evaluate the model's performance and visually, right? So what can we use? Well, this is where we need to have knowledge of the different ways of visualizing data. So we're looking at the model's performance. So it's going to be some value from 0 to 1. And it's going to be probably some kind of accuracy measure. Let's say RMSE, something like that. So we could scatter plot to visualize the predicted labels versus the true label, but that's not really useful because then you end up with these discrete points, right? Because we said classify internal documents, so we're not getting a number here, right? We're getting a category. So we're just going to get these these solid dots in a scatter plot. So scatter plot doesn't feel very good to me. And a box plot, to visualize predicted labels X versus true labels Y. Again, it's going to be just 0 or 1, right? Either you have either it's correct or it's not, right? So a box plot is not really going to help us here either, right? So then we're down to correlation matrix or confusion matrix. So a correlation matrix, remember, is to compare two values or two variables together to see if they covary or not. So so this correlation matrix may not help me here as much as well. A confusion matrix, on the other hand, is what we just talked about, right? Where we're actually looking at, well, what percentage of true negatives versus false negatives, what percentage of true positives versus false positives. So we're actually seeing, remember the grid here, right? Where we want to be on the true side. We want to be true negatives and true positives, ideally, is what we're getting the most of. And that would help me to see what's really happening. So I think a confusion matrix would fit really well here, assuming that we're classifying in a binary fashion, right? It's either positive or negative. Remember, we're just trying to identify which documents deserve further inquiry. So either they do deserve further inquiry or they do not, right? So it doesn't make sense to use these numeric approaches to evaluate how the model is actually performing. Okay, so let's take a look at another one of these 5-minute quizzes, and we'll do that pretty quickly here. What I will do is, again, just like before, I'll get you guys the link. All right, so we'll do this really quickly. And let me just paste this in here. Quiz 3. Okay. Quiz 3 can be found here. I just need to clean up the link. There you go. And here is your timer for 5 minutes. Okay, so we're getting close to 5 seconds here, and I hope that was enough time for you to explore these domain 3 questions. So when we say domain 3, we're talking about model selection or modeling. So it's the most famous of the 3 domains, and I know anybody looking to do the machine learning exam has already thought about this, right? So, you know, if you didn't realize modeling was part of this, then yeah, you might be looking at the wrong exam. So, all right, so let's look at our final domain, and we are getting close to out of time here. So this last part is easily forgotten by data scientists and by machine learning experts alike. It's very easy to forget that at some point you need to productionize this thing. All the theory is great, but if the business never derives any value from the model, then, well, nobody will notice, right? Like, I mean, it's like, well, okay, I mean, maybe you publish a paper and the universities notice your brilliance. That's awesome. That's totally awesome. But ultimately, we need to turn this into something that can actually, firstly, run on like real equipment today. So I remember back in the 90s, you know, getting into neural networks, and you know, this is before GPUs, right? So my little 486 is not going to pull it. So it was not practical. So whereas today, you know, we take it for granted. So it's got to be practical. So how do we do this? And this, it's 20% of the exam, but I think this is the most important part as it relates to AWS, because how do we actually build ML solutions that perform well, scale, are fault tolerant, they're resilient? This all sounds like operations, right? This is like what our system administrators are supposed to worry about. But, you know, the thing is, our system administrators might not fully understand what it is we're doing as data scientists. So, what can we do? Well, we can build HA and fault tolerance into any system by just literally scaling it out, right? Have more instances of whatever it is you're doing. Maybe you spread across multiple data centers, you throw a load balancer in front, and maybe you also have a DR site with a standby ready to rock and roll if everything goes really bad in your primary. So the most popular way to achieve high availability is loose coupling, right? And you know, the idea here is let's scale out. Let's launch more of our single system rather than trying to add more memory or more CPU to a tightly bound or tightly coupled system. So we already use techniques like microservices, decomposing monoliths into microservices, and so on to do this. But how do we go about doing this in terms of our data pipeline for machine learning purposes? Well, you might introduce a buffer in between the process. So let's say you've got you have a process where you want to classify images. And you want to do recognition on these images. So you can upload these images into S3 bucket. That can be set to a trigger that writes a message into a queue. And then maybe you have a Lambda over here or something like that that's triggered off of that. And then that triggers recognition to go and process that JPEG. So the JPEG gets fed into recognition. Recognition pumps out a bunch of metadata. And that metadata could be written into a DynamoDB table or something like that, right? So yeah. So CloudWatch is your monitoring, your observability portal, if you like. So just remember that CloudWatch is where you go to view metrics and logs. Okay, so for the purpose of this exam, you know, for any of our services, you can go to CloudWatch and you have full instrumentation over the services, including SageMaker. Okay, so that's really the takeaway here. So CloudWatch allows you to see the logs. You can consolidate your logs into CloudWatch logs. You can trigger events off of CloudWatch as well and say, okay, when this happens within the AWS API, then trigger this Lambda or write this message to a notification topic or something like that. And you can also set thresholds. They're called alarms, by the way. So you need to know that term, CloudWatch alarms. They're not called alerts, they're not called thresholds, they're alarms. So this is, again, hopefully nothing new to anybody here. You know, you've seen this in technology where you're monitoring a metric and saying, if this metric exceeds a value, then do something. CloudTrail is how we generate the logs from our from AWS itself. So this is not to be confused with CloudWatch logs. So your CloudTrail can be written to CloudWatch logs as a repository to hold them, or you can just throw them into S3 for longer term storage. Glue and SageMaker. So they're different, right? Because your ETL, this is the actual data preparation, is a very different mentality than doing machine learning, right? With machine learning, we're usually doing more experimentation, we're iterating more often, and so on. Whereas ETL is kind of that drudgery, you know, shoveling data from A to B. So, but very important, because if you don't have your ETL done, then obviously you're not going to do any training. Just be aware that Glue is different than SageMaker, right? The actual processing, you're probably not using a lot of CPU for ETL. For ETL, ETL tends not to be CPU bound. It tends to be IO bound, right? Whereas with SageMaker, because you know you're dealing with you know, doing training and stuff like that, you might be consuming more CPU or possibly even GPU if you wish to have GPU acceleration for your framework. Now, once you actually have a model ready to be productionized, SageMaker has a feature called endpoints. Okay, so endpoints is basically a load balancer, an ALB, that is managed by SageMaker and hidden from the data scientist. So this allows the data scientist or the machine learning expert to spin up their own endpoint without being a system administrator. You don't have to worry about like setting up load balancer and setting up weights and all that kind of stuff. So all we're showing you here is that we've got these endpoints. They're highly available across multiple availability zones. They're hosted by SageMaker, so you can take your model and productionize it behind an endpoint without much effort. So it's very easy to take that Docker image from ECR, slap it into an endpoint, and you're ready to go. So there's two real phases to your pipeline. One is doing the training, right? So we use the Docker image in training mode, and then deployment, where we're actually hosting the endpoint. And again, this is all happening in SageMaker, right? So here we have our endpoint, and our clients can hit this endpoint API to perform inference. So on the back end, we're just running your Docker image in inference mode. It's the same Docker image, right? So this is where we call your Docker image with the word train. This is where we call your Docker image with the word serve. And again, if this is foreign to you, go check out the SageMaker documentation, maybe build a custom image at some point. We even have good examples in AWS samples. Work through that, see how this works. Now on the exam, we're not gonna, I mean, you might get one question on this. Remember, this is 20% of the exam, right? So, but I think the more you know about SageMaker, especially building a pipeline in SageMaker, don't just read the docs and think you know it. You actually have to do it. So spin up an account, go into the console, build up a simple pipeline, and try it. You know, give yourself an hour, 2 hours, right? Don't try to cram it in 10 seconds here, right? So of course we have auto scaling behind the endpoint, so that's no surprise there. So auto scaling helps you to avoid errors like you know, undersizing or oversizing your instances. And also respond to changes in workloads, plus also give you that resiliency that you want with redundancy. So best practices when designing HA, consider auto scaling as a way to manage your endpoints. Use managed services like Lambda sitting behind API Gateway, because these are fully managed, right? You don't have to worry about HA in these cases. This is completely up to us to take care of. And for your endpoint, because you can use SageMaker for this, right? SageMaker is taking care of all this for you. So you're not being a system administrator. So be familiar with our deep learning containers. We actually have some images and AMI actually for deep learning as well. That's mentioned on the second point here. Be familiar with auto scaling, that it does exist and you can use this in conjunction with our endpoints. Definitely be familiar with our GPU instance types. They start with the letter P. Okay, so the latest generation being P3. And know where to get your metrics as well as your logs. Okay, so that's, again, sort of common across all of AWS, I think. Now, next subdomain, recommend, implement appropriate ML services and features for a given problem. So for ingestion, consider Kinesis for streams, Glue for batches, and EMR, I would think, is sort of more, I would characterize it as a little bit more legacy. So think big data, think Hadoop. So this is more on the ETL side, but very batchy. So you'll probably only select EMR as an answer if you hear something like, or you read something like Hadoop, okay, or MapReduce. That's the MR of EMR, right? And then use SageMaker for everything else. Okay, so SageMaker is for, actually constructing the model, doing development, kicking off the training. You can kick it off from SageMaker even to use the training service in the back end. To do tuning, tweaking, parameter searches, all of that can be done within SageMaker. So, so we have multiple stacks, we have multiple tiers rather available in our machine learning stack. So what do we mean by that? Well, at the very lowest level, this is where you are actually spinning up your own EC2, you're using frameworks, you're writing your own custom code. Everybody thinks this is what machine learning is about. It's all about just writing your own stuff, running your own hardware. And yeah, we have inferentia, we have all kinds of cool things you can tack onto here. Be familiar with all of this. But here's the deal. This bottom tier is very low level. This is really for practitioners that are working at the framework level, real machine learning, deep dive type people who are looking to write their own custom algorithms, right? But most customers don't need this. In reality, most customers really just want to solve a business problem. So you can just, well, oh, sorry, we're not there yet. With SageMaker, we have tools to help you with this so that it's easier. We're not replacing your knowledge of TensorFlow. We're not replacing your knowledge of MixNet. You still have to have that knowledge. But what SageMaker does is it just orchestrates all the moving pieces for you and just makes it much easier. Okay, so if you're a pilot of a plane, it's just like having autopilot, but you still have to tell the plane where to go, right? It's not like you just press a button. But here's the thing: most businesses just want to press a button. Data scientists are expensive. Machine learning experts are expensive. So even if that's your profession, this is what you make your living off of, don't turn everything into a complicated problem. If it's something that can be solved with one of our AI services, look at these first. Because I'll tell you right now, if you can solve your client's problem in 5 minutes, you're the hero. So you need to be familiar with the different services that are available at the high level as well, because on the exam, it may come up, right? So if you're just looking for something that can be easily built into your application, but you don't want to apply a lot of machine learning expertise, you might just use our translate service to translate from one language to another. Or you might use comprehend, or you might use transcribe, or one of my favorite, recognition. Right? Or textract. I really like textract as well, so I kind of specialize in those. So textract, why should I build my own OCR? I mean, it's been done, right? So the thing is, sometimes reinventing the wheel is just not worth it. And these APIs are fairly inexpensive. They're less expensive than our time. And that's how you look like the hero to the client, right? In the end. So if you can provide a solution in 5 minutes and the other guy takes 10 days to do the same thing, you look better. Even though you didn't author it from scratch. Just again, your business unit doesn't care. They don't care if you wrote brilliant code or you're just using a service that's already been written for you. The question is, are you delivering value to the business? So be aware of these AI services. That's very important. Okay, so for this subdomain, apply basic security principles. Yes. So security is intrinsically built into SageMaker. So yeah, we do encryption of data in the instances that are backending the notebook. There's encryption. You can run this all within VPC. Yeah. So point is that we have security for SageMaker. You can run your instances in a VPC. That gives you network security. And you can also attach a specific role to your notebook so that it's all integrated with IAM. The data that you're reading and writing to, if you leave it all in S3, S3 of course supports encryption. So just be aware that we have data protection at rest. This is all through S3 and also within your notebooks for the EC2 instances with EBS encryption. We have compliance with a number of different programs and so on. So again, be aware of the basic security functionality of AWS in general. So if this seems like a lot to know, it is. This is a level 3 exam. Okay, so it's considered a specialty for a reason. Okay, so like I said at the beginning of this morning, I did say you do want to have, you don't want to forget all your basic AWS. You should still know that too. All right, so and all of this that we're mentioning here on this slide is, in my opinion, basic AWS. Now, in terms of SageMaker, you just need to know that SageMaker does encrypt by default all the EBS volumes that backend the EC2 instances, so you're covered in that respect. And that's really the only thing that makes SageMaker special. The rest of it is just standard AWS. And then finally, actually getting these models deployed. So, knowing how to use those endpoints, doing the canary testing, you can do A/B testing or ABC testing. You can do weighted, load balancing between them and all kinds of stuff. And let's just look at some examples here. So first, you create the model in SageMaker, right? Then create an endpoint config. That is going to be the front end for your clients to hit. And then create the endpoint by providing config to SageMaker. You can, so you create the config, then you hand the configuration over to SageMaker, and now you're live. So when you deploy a model into production, you should still apply basic software engineering disciplines, have error recovery code. So you're looking for production, right? So you might use common DevOps tools like code build or code commit to automate. Code pipeline also should be on this slide. Yeah, basically all of your DevOpsy production type considerations apply when you're dealing with ML models. Basically, machine learning models are the same as any other software, right? I mean, in the end, it's just software. So when you actually publish your variants to the endpoint, we can automate the scaling of this. Remember, I mentioned the auto scaling. So that is definitely an option. Okay, so we're using the same Docker image as I mentioned earlier. So it's the same Docker image for both training and inference. Okay, so you pack both sides of the software into the same image, and then SageMaker orchestrates this for you behind an endpoint. So you should go through a pipeline and be familiar with how to actually get this model online. To that end, if you are interested in learning more about this, we do have a deep learning one-day class. It's called Deep Learning on AWS. We do actually go through that pipeline in that. We also have practical data science on SageMaker, where we go through the same pipeline, but not so much with respect to neural networks. Right. So define, apply scaling policy that uses CloudWatch metrics. So have your scale out, your scale in tied to actual metrics. So the ecosystem. So doing A/B testing with SageMaker, you can deploy multiple variants and then configure the endpoint with load balancing between them. So you can say send 80% to variant A, send 20% to variant B, and then you can see how well that's performing. And you can always build your own custom Lambda as well if you wish. So let's look at some questions. This is what you guys are waiting for, right? A sports and betting company uses machine learning to predict odds of winning during sporting events. It uses SageMaker endpoint to serve its production model. The endpoint is on M5 8x large instances. What can the company do to ensure that this endpoint is highly available while using the most cost-effective and easily managed solution? So it's a single instance. They want highly available. Those are the things that kind of pop out to mind for me. And also they're not looking to spend crazy money. So, what can we possibly do? So we can add an elastic inference to the endpoint. Well, adding a GPU doesn't make it more available, right? Increase the instance size to Okay, but that's still a single instance, so that's not helping with availability. It might make it faster, but create another endpoint. Put the endpoints between an A and B. That sounds possible. Or increase the number of instances associated with the endpoint. Well, so these two options would increase availability, except I would say A is more cumbersome. You need to know that it is possible to put multiple instances behind a single endpoint. So B seems to be my best choice. That's how I eliminate these things, right? So I say, well, look, my goal is to increase availability. This doesn't do it. This doesn't do it. You just need to know what availability means, right? And then in this case, it would work, but this seems more cumbersome. We're creating more pieces. We're creating an ALB in front of two endpoints. Why do we do that when a single endpoint can easily sit in front of multiple instances? It should be pointed out the endpoint is a fully managed service, and so on, right? This is SageMaker endpoints. So, and just ignore these, the slides, the lines are going through the wrong things. Trust me, the answer is B in this case, okay? So it's B. Next question, healthcare company wants to deploy an ensemble of models behind a single endpoint with minimal management. Models include XGBoost model and a CNN on an image data set. What could we do? Well, we have a single endpoint. We don't want a lot of management overhead, and we have two models we're trying to put behind them. And we call this an ensemble. I don't really want to get into that here. So yeah, so what could we do? Well, if we create a Lambda function with API gateway pre-processing incoming data, that seems like a lot of work. Yeah, I don't know if I like that. Deep learning container that pre-processes incoming data. Container then creates the prediction from all ensemble models, and finally it returns the prediction. Okay. Create an EC2 instance with a deep learning AMI that, okay, but now we're building our own EC2, so that's not using an endpoint, so I don't know if I like that. I don't know if I like A. And then create an Amazon SageMaker endpoint that pre-processes the incoming data. Endpoint then creates the prediction from all the ensemble models, and finally it returns the prediction. Okay, so we're kind of down to B and D. So, So container predicts from all ensemble models. So it really seems like B might be the best choice because we only have one container, right? So whereas here it sounds like we're trying to feed it to multiple models, and an endpoint can't do that. So you need to know with an endpoint, your call gets sent to one of your models. So again, my slides are a little bit messed up here, but yeah. So they are a little bit messed up. All right. So, okay. So let's do our last quiz for the day. We've got a quiz 4, can be found here. This is our last domain, and then we'll quickly talk about registering for exams and close off the session. So let me just do that really fast here. And that was not. Okay, so let's see. The last piece here. All right, so let me give you your last quiz for this session, which will be on this last domain. And remember that we will be sending a follow-on email with additional links, as well as a longer quiz of 35 questions you can try. Okay, so there's a larger comprehensive quiz that you will all be receiving by email after the session is over, where you can actually go through a larger number of these questions, and it covers all the domains. Okay, so you can go give that a shot after. But here's 5 minutes for you to look at this last quiz. And I want to thank you for joining us for this session. I know some of you may have a hard stop given that the session is 3 hours. Okay, so we've got about 10 seconds left here. I want to thank you for joining us this morning or this evening or whatever time you're in, and inviting Joe, Chris, Darren, and myself to help you out on another small step on your AWS journey. I hope that this last quiz worked out for you, the domain 4 one. And like I said, we will be sending another link to you for a comprehensive quiz. So you'll actually get like a 35 question edition of something similar to what you just did there, but it'll be like a much fuller practice for you. So in terms of study materials, we will also be sending you a list of additional links for white papers, documentation, the official exam guide, as well as other digital training that you can take for free. So I apologize for going a little bit over on this session, but I guess that's us trying to make sure we can pack as much into these sessions as possible, and I hope it's been useful to you. Just want to point out that when you're ready to register for your certification, you log into our training portal, which is at training aws.training, and you create an account here if you've never done so before, but probably you already have one. So you log in, click on certification, and then over here go to your account, and then find the exam in question, which for this particular session is AWS Certified Machine Learning Specialty, and schedule, let's say, with Pearson or PSI. The exam cost is $300 US for the exam, and if you wish to also go through a practice exam, you can pay $40 for a practice exam that you can take online, which actually gives you, I think it's 30 questions that you do online to see how you're doing. So the point is, again, from these 3 hours, hopefully you have a better understanding of the scope, the breadth of this exam. It is not narrow focused. It's a lot broader than what most people think, so be prepared for that. Now, in terms of signing up for the exam, well, the things to do would be you need to obviously sign up for it. You cannot just show up at the testing center and say, hey, I want to take the exam. You do have to sign up for it. And you should work backwards. So whatever date you choose, pick one. That way you're not putting it off forever, right? But then work backwards. Think about what you didn't get in this review.